Thank you, Marinos, and welcome everyone. It's really a great pleasure and honor to be here. I'm amazed, Marinos, at the diversity of countries and people you've been able to bring together around this important topic. You can hear me okay?
Yes.
Good. All right. So I'd like to give just a quick introductory remark about the importance that the European Commission indeed and Europeana is currently giving to the topic of 3D. And also some of the challenges that we're facing that hopefully today this symposium will help to clarify at least to some extent. So let me share my screen. There we go. Okay, Marinos, give me a thumb up if you can see all this. We're good? Yeah, excellent. So, so the subject of today is Paradata, Metadata, and Data. I think it's important to realize when we talk about this is that as a sector in Europe, at least, we've had now 15, 20 years of experience managing that kind of information, but mostly in a 2D environment. As Marina's already said, the interest in 3D has increased quite drastically and dramatically over the past couple of years. So that brings us into a whole new level of complexity in order how to handle the kinds of data that are associated with 3D in particular. So why is 3D all of a sudden so relevant and so important? Well, I think there are several aspects to that. Most importantly, probably that we're now moving into a virtual world environment that will require a lot more 3D expressions and experiences. But when we think about why the policy area is changing about 3D, there are three main drivers for this, in my experience. So the first one is that 3D applications really provide unprecedented opportunities for access. We can reach wider audiences, not only in 3D, in virtual environments, but also very much so in 2D and 3D printed environments for people with issues with accessibility and visual impairments. Preservation has taken center stage. I think climate change has been one of the most important drivers. Wars on the borders of Europe, all of these have made preservation of 3D and monuments and sites in particular incredibly relevant at the moment. And we do not have a proper digital answer to this until this date. And finally, the reuse opportunities, the stimulation of tourism, creative economies, and so forth, that can really help if we have a proper 3D framework and digital objects readily available, as we did and do already in the 2D environment. So those are the three main drivers that we've seen. It has led to a number of big policy initiatives. The most recent one, I would say, are the recommendations from November 2021, which encourages all the member states in Europe to accelerate the pace of digitization, and most prominently, the pace of digitization in 3D. As we know, currently, the level of 3D digitization is still really, really low compared to what we've known in the field of 2D digitization. So that was the reason that the European Commission, together with the Europeana Initiative, launched a Twin-It campaign, as we call it, 3D for Europe's culture. It spanned 3 presidencies, and the main purpose of it was to raise awareness on the highest possible level in the European member state ministries of the importance and the need for 3D digitization. So the ask was really simple. In my opinion, we asked every ministry from the 27 member states to submit at least one 3D object to be submitted as part of this emblematic campaign. Of course, that was only to create awareness. What we hope is that in the slipstream of this, a a lot more awareness and capacity building efforts would be developed, more funding would be associated with this, so that we can accelerate the pace of 3D digitization. And I think several projects, Eureka 3D, for example, is a good example of that, is also leading towards that. As I said, the policy directly supports the Commission recommendations of 2021. For those of you not familiar with it, that really there are some targets associated with this recommendation. It's soft policy, as they call it. It's not the law, but a strong encouragement to digitize millions of objects. In fact, Commissioner Breton has stated in this recommendation that his ambition would be to digitize all monuments and sites at risk in Europe, as well as 50% of the most visited by 2030. Of course, the verdict is still out on the definition of those terms, but it tells you a bit about the ambition level that Europe has. So what is the result? We're now closing in at the end of the campaign, and I can say, with some pride, that we have achieved a really interesting, emblematic collection of 3D digitized assets from almost every country in Europe. And I'll give you just a few examples. I can't, unfortunately, due to time constraints, tell you everything, but I think you can already see the richness of it. We have from Belgium a millions of years old skeleton, an iguanodon, that was uncovered in Belgium. From Cyprus, of course, we have the important fortress from Paphos, already there in the Byzantine times and reconstructed several times, at risk, and a UNESCO heritage site. We also have statues here from Italy, an incredible, more than life-size version from Hercules. We have a crown that has crowned apparently over 50 kings in Hungary, a very important paraphernalia. A globe from the 17th century from the Netherlands, but also an entire archaeological site from Delphi, from Greece. So the combination of these things, and here you see a few more. We see from Denmark a fantastic bronze statue of a mermaid, one of the few that was designed by a woman artist. We've got on the right-hand side from Belgium, late Middle Age statue, Madonna Lactans, and it goes on. So I think with this campaign, I think we've been able to show that if we pull together as nations in this important endeavor, we can really bring together the most important things and the richness and the vastness of heritage in Europe. But of course, that's not the end of the affair. In order to really reach the ambitious targets we're setting for ourselves by 2030, we need to get a much deeper understanding of this area, both on a technical level, but more importantly, I think, on several other levels. So there are four big takeaways I wanted to share with you at the start of today's conference. The first one is that, and I think this almost goes without saying, but that this is too big a task to solve for any country or any institution on its own. It really requires a big collaborative effort. Marinos, yourself, you've been involved in many recommendations. We need to design, what we think the frameworks are, the quality levels that we need to design in, and we need that to make it a collective effort. The second thing is that in order to reach our quantitative targets, we really need to take a qualitative approach. And what I mean by that is that it really depends on the use case. Excuse me?
2 minutes.
Yeah, almost done. It really depends on the use case here. Is it for preservation? Is it for reuse? Is it for accessibility only? That needs to determine the level of quality of digitization that you put in mind. It will have huge implications financially, but also for climate considerations, depending on what you do. The third one is that with 3D, we're also entering a new terrain of digitization, and it'll have licensing consequences. It's my conviction that we need to secure that also the public domain remains an attractive and interesting place, and that we do not impose too heavy copyright restrictions on all these three, on 3D digitization. And finally, it really is the subject of today. We need to understand much better, have a common understanding of what Paradata means. How do you secure that? Where do we safeguard it, store it, and how that relates to data and metadata. So this was my introduction, Marinos. I'm hoping that we'll have a very fruitful and interesting conversation. I know many of you will have very interesting thoughts to add to this. So I'd like to leave it at this. Congratulations on bringing so many different countries and people together on this important subject. Thank you.
Thank you very much, Harry. I made some notes from your introduction, and the most important, I will start here, put the nation's content together. But that's what we are. We are the European Union, isn't it? And that's where all the member states are together. And Article 3 of the Carta for the creation of the European Union is saying clearly that we are whatever we are as a union because we have something common together. And that's our common culture, yeah, our common history. And this brings us under one roof. And you are the captain over there in one of the most success stories. And we help and we support you even from this side of Europe. I will share now my presentation. So, ladies and gentlemen, first of all, thank you very, very much again for coming together here today. It's all about Paradata, metadata, and data for a digital memory twin. If we digitize the past, we digitize it because there is a reason. There is a value. There is a story. There is knowledge. There is, at the end of the day, a memory. And out of that, we want not only to protect that, but also to keep it alive. And that's one of our main objectives of the project Eureka 3D, which is funded by the Digital Europe Initiative, and where we are a part of it. Now, the UNESCO Chair on Digital Cultural Heritage, who we are, yeah, we are the chair of the UNESCO chair with the name of Mnemosini. The name from where it comes from the ancient Greece, from the mythology, goddess who had 9 daughters responsible to keep the memory of the ancient Greeks alive. They had a common space, a common temple, which is the name or in almost all the language of the world still alive, museum. And the ancient Greeks went to this museum to do what? To keep their thoughts, their memory alive forever. So, and our duty is also to do that. Now, we are developing new approaches to heritage digitization, 21st century, digital transformation, and so on, managing digital cultural heritage knowledge and memory. That's why we are talking about memory twins. And if it's all about the monument, then it's not a building, yeah? We see 3D objects. Harry presented them earlier there, but as humans, we do the interpretation. Yes, they are ancient. Yes, they are monuments, all those buildings. Now, the issue is how do we present a monument online? How do we digitize it? What the kind of information we keep, how we bring everything together. So building innovative cultural heritage experiences, promoting use and reuse of digitized collection, world-class impact in research collaborations, and this is what we do here. And we're trying, at least with the, to set some standards, guidelines, norms in the area of digital humanity. So Paradata, let's start from the first important word here, which creates also the challenge of the event, information about the human processes of understanding and interpretation of 3D data objects. Paradata are adopted in the London Charter, in ICOMOS Principle of Sevilla, NME chapter, in the recent published EUVG 2020-654 study, etc. It's not a new word. It's an old one, even from the ancient time of the Greeks. Paradata has evolved in now encompasses many aspects of the digitalization of cultural heritage, and of course, Paradata, metadata, and data are accepted as markers of quality. So now, this series of webinars seeks to understand how Paradata is currently used, who, when, and how to use Paradata, how Paradata can work with metadata and data, start to define a common standard for Paradata within the domain of digital cultural heritage. Now, computer science, information science, and all this what it is under Europeana, and this what we do also in the Eureka 3D project, information and data. That's what we have at the end of the day when we digitize something. And out of that, we need to have the knowledge, the memory. If we digitize a museum, which is defined as a space of knowledge, then at the end of the day, this virtual museum has to be a place of memory as it was in the ancient time of Mnemosyne, or a space of knowledge as it is defined today. Information, it is the paradata and the metadata, and the data is the 3D object. It's all together is the memory of the past. And now an example, a very, very good example from Cyprus, not so far away from here, the oldest vessel in Cyprus, a fisher boat, the so-called Lambusa boat, which is also a case study in the Eureka 3D project. You see how the ancient boat was. You see also here the modern digital twinner as it appears here. And then the complexity, how different parts are together so that we can create the vessel out of that. And that's just only a part of it. But if you see here, the table of materials and all this, what it is here together, we bring it under the roof of complexity. And here is where we start with the stakeholders, and then how we digitize it, how we bring all together, and under which conditions and so on. That's the biggest part of the job under the data acquisition. Now, from the point cloud to the 3D model to the space of knowledge and so on, to keep the memory, that's a procedure, that's a profession, that's a new job in the new era for the new generations to come, to create this kind of data sets, memory sets for us to keep and preserve for the past. And by saying this, I'm coming to the end, and thank you very, very much. I think I managed to send the message in a quick one way. And I would like to welcome Isto. Isto is currently in New Zealand. He just landed there to participate in the CAA conference. Isto is the coordinator of one of the most important projects currently in the domain of Paradata, a European Research Council funded initiative and project. And Isto is going to give us his position, his knowledge from his project. Isto, the floor is yours.
Greetings, everyone. I am going to talk today about the imperative of Paradata. That is, of not only documenting 3D visualizations as things, but retaining necessary information for maintaining understanding of the making and processing of 3D visualizations, and in a broader sense, all scholarly outputs, including research data. My name is Isto Huvila. I'm working as a professor of information studies at Uppsala University in Sweden. One of my major areas of interest for over 2 decades has been archaeological information work, the management of heritage information, and 3D visualizations as a form of information. We have witnessed huge leaps in digital research and curation of the past during the past decades. Many of the early promises of cultural heritage visualization has begun to get realized for real. The human past is becoming better accessible for research, formal and informal education and recreation. We also know more about how to effectively manage the rapidly accumulating corpus of visualizations and in general data about the past. We have standards, and we know better how to describe assets to make them findable and useful. What has, however, so far received less attention is how to document practices and processes involved in the making of diverse assets meant to be reused in the future. The importance of documenting making and its intellectual underpinnings was acknowledged already at the turn of the millennium, and it was incorporated a few years later in the heritage visualization context, and not least in the London Charter document. But in spite of these efforts and attention, or the imperative of Paradata, it is still very much a problem without an apparent solution. The key problem is that we might know what a 3D visualization is about as per typical metadata, but without a thorough enough understanding how the visualization was made, data was processed, and decisions leading to the final result were made, we have difficulties to know what it is good for when we want to use it for further research, education, public display, or elsewhere. The problem is that it is typical to think or act as if we would be thinking that when a visualization is made and passed on to secondary use, we are literally giving or handing it over to others, or ourselves as secondary users, with everything needed to know about it, and that there is a connection between makers and users of visualizations, which is not really quite true, as the most of us would undoubtedly agree. Creating and using or reusing 3D visualizations could not be farther away from just handing over a ready-to-use things. It is really more like that the creator of a visualization is casting a seed on the ground where the secondary user eventually might find it, attached with some documentation, but often far from adequate to directly understand how it was done. It has to be sown, watered, and grown for the purposes of reuse with a lot of care and consideration. This is where Paradata kicks in. It is somehow conventional to define Paradata by contrasting it to metadata by saying that metadata is data about data and Paradata is data about processes and practices. While this makes sense per se, it simplifies the big picture. To avoid losing what and where Paradata can be found, it is best understood as a broader type of informative things, some of which is often represented as in standardized metadata elements, but a lot of it falls outside of it and can be found elsewhere. To open up a little the idea of the category of things that can be taken as informative could be to simplify it a little and say that it is data or information on practices and processes of making, processing, and using things like 3D visualizations, research data, and more. At the same time, acknowledging that it depends on the individual user what actually counts as such information or data. Me and my colleagues have been investigating Paradata, where it can be found, what it is, and how it works, here with the current members of the team. The current project is called Capturing Paradata for Documenting Data Creation and Use for the Research of the Future, or CAPTCHA for short. And it investigates what information about the creation and use of research data, that is Paradata, is needed, and how to capture enough of that information to make the data reusable in the future. Why this is important in general, and from the perspective of 3D visualizations. Plainly, without Paradata, we can see 3D visualizations, but we can't see how they do their job of representing what they attempt to represent or convey. Paradata is an issue of conveying understanding, but also quality, as defined separately in each context of use by the actors who are involved in the process. Paradata is needed for reusability of 3D visualizations, reproducibility of the visualization work, but also of learning and drawing any conclusions on the basis of the visualizations. It is needed to assessing the reliability and trustworthiness of the visualization and its adequacy for the purposes it is used. Fundamentally, it is necessary to make visualizations understandable. Paradata is for everyone. It is not the concern of data managers or researchers only. Similarly to how Paradata is everyone's concern, ideally, it is also everyone who benefits or suffers from poor or lack of Paradata. Researchers, institutions, industry, citizens, you name it. Correspondingly, it is also everyone's responsibility that there is relevant Paradata for all key stakeholders. As Hostetler and colleagues note of digital archaeology, also with Paradata, start quote, the issues at stake are central for the field as a whole and should not be left to digital specialists or funding bodies alone. End quote. Everyone interacting with 3D visualization needs to be there, including researchers, but also everyone operating with 3D visualizations in the society. What is then this Paradata in practice? First, it is not a copy. Our host today, Marinos Ioannidis, makes a distinction between a digital twin as a full copy and a memory twin that can be perhaps understood as a complex of documentation that makes it possible to walk back the process or practice to a degree that makes it understandable. Incidentally, this is rather close to being a twin of how Nicolucci and colleagues defined a digital twin as, start quote, the complex information about the digital counterparts of real-world heritage objects, both material and immaterial ones, end quote. Independent of the terminology, it is however important to make a distinction between a digital twin as essentially a copy or a virtual representation of an object or system designed to accurately reflect a physical or immaterial object, and Paradata that aims to make the objects understandable and enable interactions with the objects themselves. In addition to distinguishing Paradata as a kind of information, we have inquired into the Paradata phenomenon from the perspectives of looking what people describe they need to know when they are referring to Paradata-like information, and what types of information function as Paradata. As per needs, we have identified so far that Paradata on research data is needed for 4 major categories of purposes. Transposed to 3D visualizations, it is needed to understand the scope of assets, how the visualized entity was selected and framed, what is covered, what methods were used in collecting initial data, what was provenance, including the disciplinary origins of the data collection and making of the visualization, its epistemological underpinnings and underpinning rationales, what methods were used in creating the visualization and what decisions were made, and finally, how knowledge is represented and organized in the visualization, what standards and formats were used, what semantics for representation, links, etc. Similarly, to exemplify using typical elements of archaeological field reports, what types of information can function as Paradata, also with 3D visualizations, we can document and find Paradata in references to the literature, photos and visualizations of the visualization work, and what was visualized in names of methods, tools and actors, narrative descriptions, and also in the visualizations themselves that contain traces of how they were done. The fact that much Paradata can already be found in existing documentation means that the main challenge with process documentation is not necessarily to expand its quantity or scope. One of the problems is that the Paradata is fragmented across different parts of the documentation, and that it can prove complicated to get an overall grasp of what Paradata is available. Key challenges involve finding the Paradata, understanding what is missing, and complementing it with the necessary additional information. The key issue is that we need to document enough and not too much. This can help us to avoid exhaustion, as more documentation is largely just more documentation, while the amount of useful information increases much slower. So in practice, it is crucial to document useful information. Saying that it is vital to document information that is useful may sound like a no-brainer, but it is hardly that in practice. We document a lot of things we assume are useful without that much consideration if it is really true. We also typically think that what is useful for us is useful for others, which is not necessarily quite true either. Documentation is time-consuming, expensive, and often boring, and demanding too much of it is bound to decrease its quality, because if too much is required, there is not really time and possibility to focus on it carefully enough. Therefore, it is critical to think about and document specific scenarios of how the 3D visualization could be used, by whom, and what Paradata is necessary for that. This applies also to thinking of what Paradata is needed for making useful visualizations findable for specific stakeholder groups. The explicit documentation of Paradata could be thought in terms of a workflow. First, to identify what needs to be known with a focus on real needs rather than wild guesses. Second, check if that information is already somewhere in the documentation or elsewhere, either usable as it is or with some editing or processing. If it is there, it does not need to be documented again, just linked to the documentation. Finally, document what is needed and not covered elsewhere, and do that as it is appropriate. Enforce standards where it is useful for improving findability, machine operability, and usability for identifiable purposes. Otherwise, let people document as fits best for their workflows and episteme. While Paradata is acknowledged to a certain degree in different standards, the mechanisms of representing it tend to be either highly complex, as in CyDoc-CRM, which is really great and comprehensive, or very simplistic, for example, a free text field called Paradata. This means that in practice, for an average maker or user of 3D visualizations, the existing standards easily lack actionability. They are too difficult or time-consuming to use, or too unspecific to be helpful. Moreover, what is missing is a clear understanding what exactly needs to be documented according to the standards for different purposes. Our work in Capture project provides important building blocks to this end, but there's a dire need for concerted efforts across domains to figure out in detail how the generated principles and observations can be made actionable. In addition to standards and standardized Paradata, another must is avoiding the temptation to try to make things too clean or simple. Redundancy is a must in all documentation, as Kruse and Schönenberger recently reminded us, and so it is also for Paradata. In fact, redundancy and keeping a lot of data, working versions of the documentation, is the most important source of Paradata. And even if it's costly and burdensome to keep a lot of redundant data, the great advantage of it is that it is already there and does not need to be generated anew. Without both adequate traces in working documents and residues of visualization work, and intentionally generated ingredients for understanding it, we don't have much left that makes any real sense. Keeping these traces is crucial for maintaining adequate understanding of the 3D visualizations we make. It applies to visualizations of tangible objects and data on intangible practices, phenomenon and things. Incidentally, much of Paradata itself is meandering somewhere between tangible and intangible. It is documenting processes and practices with indisputable materialities, but that are at the same time to a great degree difficult to grasp, capture, and stabilize as the ideals of formal documentation would expect. From this perspective, Paradata unfolds also as a critique of the idea of heritage and everything we are dealing with, both in scholarly sphere and in the totality as the things we can capture, keep, and stabilize, but also as a method to approach that what really can't be stabilized, and still to make approximations of them to make them comprehensible, manageable, actionable, and intelligible for both us and the others at the present and in the future. So to conclude, we have an imperative to deal with Paradata. If we fail, we end up having piles and piles of 3D visualizations that are only marginally useful and usable, if at all. What makes this all difficult for real is that, as you well can see, we are not dealing here with a clearly delimited and easily solvable problem. Just adding a couple of additional data points to a visualization does not do the job. We have to understand and preserve both formal standardized and informal information that are both critical elements of Paradata that aspires to be complete enough to be usable.
Thank you very much, Isto. Your video was very Your video was up to the point, and thank you very, very much for being with us today in person. We do know that in New Zealand now it's very late or very early in the morning. It's highly, highly appreciated. Hope to see you soon with us here in Cyprus. And we move to the next presentation, which is coming from Paris, from two divisions, I would say, of UNESCO, the UNESCO satellite division, the training one, it's three, not two, three, and then the World Heritage Center. Luisa, the floor is yours, and thank you very, very much for your contribution and for being with us today. Thank you.
Thank you, Marinos. Actually, UNESCO side is going to start with this presentation. So thank you again for the introduction. My name is Thomas. I am a project manager at UNESCO. And today, together with my colleagues from UNOSAT, we will be talking about Paradata and metadata in an immersive digital experience. So when we are talking about Paradata and metadata, we believe that they can play key roles in understanding how 3D models of either historical sites or objects are created. And we believe that they are essential also to ensure transparency and reliability in digitally representing cultural heritage. But at the same time, for projects that cater to diverse audiences, ranging from heritage enthusiasts to novices, site visitors, and so on, integrating metadata and paradata into an immersive web-based structure can present challenges, as it can risk disrupting narrative flows. So the objective of our paper and of this short presentation is to explore how we can visualize metadata and paradata in a compositive 3D digital experience without sacrificing immersion or story flow. Now, the paper uses the case study of the UNESCO Dive into Heritage project to start a discussion about best practices on the representation of metadata and paradata in an immersive online environment. And Dive into Heritage is a UNESCO-led project that aims to develop an online platform which can help people learn more about our world's cultural and natural heritage by using technology to create an immersive online experience. So the idea with Dive into Heritage is to invite users from all around the world to discover World Heritage sites and also learn about their outstanding universal value, but not only about the tangible values, but also linking intangible or living cultural heritage values. And doing so using the latest technologies such as 3D models, high-resolution videos, and interactive maps. And UNESCO has partnered with UNOSAT, it's a UN sister organization, to develop a first functional prototype of this platform. So the platform is not launched yet. We are still developing the prototype currently. And last but not least, the project is generously funded by the Kingdom of Saudi Arabia. And we are focusing on a very concise or limited selection of 10 pilot World Heritage sites in the Arab states region only during the first phase, so North Africa and the Middle East, with the aim, of course, to digitize all UNESCO World Heritage sites eventually, considering that there are currently almost 1,200 sites inscribed on the World Heritage list. So currently we only have the 10 sites in the Arab states region. Each of those sites has multiple 3D models and multiple other digital media that we include in the platform. And so you can imagine the amount or volume of the data if the Dive into Heritage platform eventually will encompass the whole UNESCO World Heritage list. Now, the project focuses on delivering an accessible experience targeted at a wide audience who are invited to explore World Heritage sites in an unprecedented way. So we aim to offer users multiple entry points into the experiences, such as a streaming platform like Carousel to a 3D globe where all the 3D models can be accessed on. And while 3D for the Diving Heritage project is indeed front and center, our approach is to combine multiple types of data. So not only 3D, but also 2D, such as images, video, and interactive maps. And this way we aim to craft a rich but also coherent digital narrative where the user can scroll through to learn more about World Heritage sites and its values through digital technology. And aside from this digital narrative, which is meticulously crafted to offer a coherent and guided experience, we also want to provide users with a more control over how they interact with their heritage. And that is why we also include responsive 3D viewers of each World Heritage 3D model that is featured on the platform. So users will have the ability to zoom in, zoom out, pan, and so on, and have full control over their virtual exploration. Now, we of course need data to build this platform, and Diving Heritage combines 3 types of 3D assets. So just talking about the 3D, the 3 types are the reused existing 3D models sourced from states parties to the World Heritage Convention or other owners. We also have newly acquired 3D data that is captured by UNESCO or its teams on the ground. And last but not least, we have original 3D models that are modeled by UNOSAT. And today we will be just talking about 2 case studies. The first case study is Bahla Fort. Bahla Fort is a UNESCO World Heritage Site in Oman, which UNESCO and its partners digitally captured in March last year. And the team used a combination of 3D laser scans with terrestrial and aerial photogrammetry to achieve the results that I presented earlier in this presentation, where you could see the 3D models of Bahla Fort in the online prototype of the platform. And I just want to highlight the fact that we have to consider World Heritage specific metadata, such as the official property name, the date of inscription, but also very important, the World Heritage criteria. Why is it inscribed on the UNESCO World Heritage list? Is it a cultural, a natural, or a mixed site? Has it been inscribed on the UNESCO World Heritage list in danger or not? And understanding and utilizing these specific metadata categories is essential for effectively managing World Heritage. So we really need to consider some of the specifics for World Heritage. Moving on to Paradata, here on this slide are just some of the key Paradata that we documented during the data acquisition process of Bahla Fort. And we have been following some of the ICOMOS SIPA standards for documenting Paradata during the documentation mission. And the mission in Oman last March was also an excellent opportunity to test the international standards that we are developing for 3D documentation of World Heritage. And these standards are being drafted with the input from leading experts in the field of digital cultural heritage, such as also our host today, the chair on digital cultural heritage in Cyprus. And UNESCO believes that having clear standards and guidelines, as was already mentioned earlier today by the colleagues, is really key to have consistently qualitative data sets, but also to scale up in particular for the Diving Heritage project, to scale up the project while maintaining also the long-term sustainability of the online platform and the wealth of digital data it features. And I will now give the floor to my colleagues at UNOSAT for the rest of this presentation.
Yeah, hello everyone. So Thomas, if you can you share still the screen also during my parts?
Sure, no problem.
Okay, thank you everyone. So today I'm excited to share with you an intriguing case of study from our project, an instance of gathering and storing metadata and paradata for an original 3D model made for the Diving Heritage project. It is showcased through the Curfew Solar Ship at Memphis sites. So we aim to use a 3D model to present this historical artifact to the audience, but we faced a challenge because we didn't have a photogrammetric model as part of the project. So we discovered a dense point cloud on Sketchfab, which serves as our reference. And as you can see in this screenshot on the slide, the available metadata to score and store on the Sketchfab page consists of the username of the author, name and location of the ship, the number of triangles and vertices, also a brief description regarding the quality of the point cloud and the history of the ship. And as usual, the available download formats, a few tags for identification through Sketchfab, and the publish time frame. So using this point cloud as a reference, we embark on creating an original 3D model of the ship. Through the process, we encountered various challenges and made several decisions, which led to the creation of Paradata. To showcase this, Paradata, my colleague Bethany Watchers, that is the 3D modeler author of the model, initially stored on her personal online repositories this data, and then she created a presentation using Canva, which was shared during a tech talk session. So then she compiled this information into an Excel file for better organization. Thomas, can you go on with the slide? So this is the result, and the data are, I would say, self-explanatory, illustrating that for a single model, we can compile page of information. And this volume needs to be considered when determining how to present this data. Because also in our scenario, as Thomas has already anticipated, we are now discussing 10 pilot sites, each containing an average of 5 or 6 3D models. However, by the project conclusion, we foresee involvement from a number of 1,000 sites, taking into account that there are currently 1,200 sites recognized as World Heritage. So, Thomas, can you go on? Thank you. So we began exploring ways to integrate these data effectively. Consider 2 viable options, also looking at what is existing now. So there we can see the page of Steam, for instance, and another one related to Meroe sites from Google Earth and Culture. So these 2 hypotheses involve, for instance, establish a specialized section to collect all this information. But this approach may be better suited for a scenario involving a solitary 3D model, like the multitude found in Dive into Heritage. Okay. So like in instance like the latter, assigning an identifier to each model could prove to be very challenging and also maybe counterproductive. So ideally, users should have access to both paradata and metadata alongside the physical depiction of the object within the same interface. And the second hypothesis, Thomas, if you can go on, is incorporating a button or maybe, I don't know, a QR code at the page end, as we already have done. For instance, in the first 2 images, you can see this little button with the that unveils some image or other kind of multimedia to explore, having always the same window, deepen some information. So, but while displaying these elements simultaneously on the screen could potentially reduce the ambiguity in assigned metadata in Paradata, integrating this extra feature might disrupt the immersive flow and shift the user focus away from the narrative. That is something that we really want to avoid. Go on, Thomas. And so also perhaps for what concerns the globe that Thomas has showed before, perhaps also by adding the button at the particular zoom levels within our 3D globe that leads to pop-ups, we could also provide paradata and metadata for many sources of 3D data, including the numbers, eventually 1,000 of 3D models. So nevertheless, there is room for enhancement, and exploring a visual solution could be beneficial. So how will this information can be displayed? To our knowledge, there is no precedent of a digital platform generated from so 1,000 sources into a single scene. And as of now, we do not have a definitive answer, but we are here to raise a critical question. So is it truly possible, challenging to integrate a large amount of paradata and metadata into an immersive experience without compromising user exploration, but also on the other end, limiting the amount of data, the releasable data? So thank you for your attention, and let's see later during the discussion.
Thank you very, very much for the excellent presentation. Up to the point. Nice to see you again, Thomas, and we're looking forward to see you also here in Cyprus in the next time. We're moving to the next presentation, or we're moving from Paris back down to the other half of the globus in Australia to our colleague Eric Champion. Eric? Good to see you online. If you can share your presentation. Yes, you are online. The floor is yours, Eric. Thank you.
Hello, thank you. I will be as brief as possible. Hopefully you can hear me. So I will talk briefly about this human social aspect of metadata, paradata, and so forth, and some questions I have for the learned people in the room about how they can all be used. So when I have been studying this in the time I've had, I deal more with the interpretation, immersion, and understanding how people understand heritage data. And when we look at some of the references, there is confusion, as Isto and others have said, but some of the quotes haven't been taken up by the community. So one of them, and I won't have time to go through all of them, but one of them is at the bottom of that slide. When Berkeley cites Hoskins, most important is what we do with media rather than what media does in the shared memory process. And in the brief few minutes I have left, I'm going to mention briefly some projects where we've found some of these problems and why we think the civic nature of data has been missing from this discussion of paradata and metadata. So Riley and the others have an interesting paper from 2021 about 1998 discussion of paradata about distinguishing auxiliary data, describing the processes by which interview data is obtained. But if you compare that to the Vietnam Charter, which doesn't really directly address paradata, and the London Charter, which talks about process-oriented transparency of data, I spoke to the person about 10, 15 years ago, the technical person who did the 3D visualizations of the London Charter at King's College London, where he said he introduced the essential importance of this term in order to remind people that there was so much data that went into it. But when you read the charters, they talk more about the process of interpretation and understanding, and yet the data from which they've drawn, they might not be consciously understanding of what they've drawn from. So we already have a conflict between the data from which they've designed and the design data, the interpretive data they've used to create this paradata. And this is not clear in many of the definitions. So if we, for the sake of simplicity, if we go through Paradata as enhancing the understanding interpretation of digital heritage resources, which are put there in red from Rabinowitz and so forth, that sounds very good. But there's a further problem in that, and this is also the problem with the London Charter, in my humble opinion, describing how things happen and prescribing how they should happen have been merged. They've been converged. So in that definition, you will see a description and prescription problem. It describes what happens, but also says how it should be done. And so it can be difficult as a scholar to draw back from saying, well, this is how it's done, but could it be improved? And as other researchers say, this is a wicked problem. We have this problem with how much information we can put in, and I'm not going to directly address it. I'm just going to raise it. I'm going to suggest putting in some more data, and that is, how do people interpret it as a process? And unfortunately, and it hasn't, I think, been mentioned yet, 3D visualization is no longer a collection of images. It's no longer a collection of pixels. It's also code. It's dynamic. It's an algorithm, as we've seen with AI and machine learning. So how do we cope with that? That is a huge issue, which I've only just encountered recently. But my issue is a bit more, it's a bit smaller. And that is, how do we cope with the evaluation, navigation, understanding issues? So when you look at these wonderful 3D models, and then you compare what the public understood with them and the heritage experts understood with them, we see a huge gap. So we have different audiences, we have different experts, we have different technologies. Nobody is talking about navigation, which is one of the most important, difficult problems in virtual reality and immersive 3D models. And very few people are talking about the learning aspect and how that can be incorporated. So if we go back to the UNESCO guidelines, it's all about community building, decision making, participative, etc. This is not integrated into the definitions of Paradata. So I go back to Paradata already obscures whether it's related to the research collections from which the model is drawn, or whether it's talking about how people design from that data. I think we need to have separate terms. I'm afraid, hopefully I'm wrong, I'm afraid that Paradata is covering too many terms to understand, because one of the most important things about heritage is that people use it, understand it, and take it forward through generations. So where does Paradata fit in with this more civic notion of heritage as decision making? So I will briefly mention projects which Marinos and others already know about. 4 years ago, we did a project looking at 5 of the major conferences on virtual heritage, trying to find 3D models, trying to find which ones worked. At a very simple base level, metadata should be able to tell us what's working dynamically for linked open data, and it doesn't. But secondly, academic conferences and publications aren't allowing us to look at the models themselves and discuss them together. And we cannot find these models. So when we're building these models and we're creating interaction design and we're evaluating people, we're repeating what's already been done, because we can't find these models, we can't learn from them, and we can't re-verify them. So there's major issues in linking between the 3D models and the academic frameworks around it, which we still haven't totally resolved. So I'm hopeful that these large groups will resolve it for me. Second one, and this is already old, but the second paper we looked at, we evaluated many different commercial and free portals, repositories, online 3D web model infrastructures, and we tried to work out what interactive features they had and whether they served their purpose. But we concentrated in the end just on what interactive features they had for understanding the cultural significance of the model, and they're extremely limited. Sketchfab and others were perhaps more powerful, but there is a base problem, and maybe someone here has solved it. What is the 3D model for? So none of these portals are addressing that problem, because nobody's actually posed it as this is what a 3D model will do for the public to understand. And it goes back to something I kind of didn't fully specify before. A 3D model to a scholar or museum person is very different to a 3D model to a 10-year-old or a 12-year-old, etc. And this is a particular problem when you work with museums, some of whom have moved away from 3D visualization because of many different features. So I would suggest when we look at these portals, maybe a larger organization could actually look at how the 3D model, the interactive features, and the expected cultural significance, universal significance was mentioned, living heritage was mentioned, but where is the data on it actually achieving that goal? Because we actually need to improve the 3D model and the resources as a communication medium. So we also have this problem, and I found out about it when I was talking to people in digital humanities trying to preserve digital theater. One of the fundamental issues is how much do you preserve of the theater? Do you preserve the play? Do you preserve the place in which it is performed? Do you preserve recordings of the audience responding to it? And if we look at digital heritage, and if we look at the museum sector, do we record in some way the audience reaction and how it could be improved for future audiences in a future iteration? So I'm going to suggest that Paradata, or a different term, needs to also look at the reuse data, and it needs to find a way of aggregating it or linking to it. So the user experience aspect is missing from many of these conversations, and I suspect that's an essential aspect. I should briefly mention, how am I doing for time, Marinos? Have I got 3 minutes left? Okay. He's put up one thumb, so I'll say it's 1 minute. Okay. So when we did collaborative mixed reality, and different people in different headsets could see the same physical object but different mixed reality around it, we need a way to be able to convey that for the future generations of these different interpretations. So we have this technology to show the same object overlaid with different cultural aspects in terms of intangible heritage, but we don't yet have a way of explaining that for Paradata and metadata. That is going to become more and more essential with the development of easier and more powerful VR headsets. So I've worked the last 2 years in workshops around Europe and Asia with people designing games, augmented reality and mixed reality projects, in order to try and find out what would make it engaging for them, and whether from what they learnt they could then educate other people to build open-ended games. So we have been talking about UNESCO sites and models as closed-ended processes. But what happens when a community part owns it, and a community wants to extend it, and a community wants to have alternative interpretations of it? Do we need to start thinking about these models and visualizations as open ecosystems, of scholarly understanding, but also of public sharing and understanding. So there is that issue as well. So people have talked about crowdsourcing to extend, say, the British Library, the British Museum, and many museums and so forth around the world. But we still have a gap between the professionals and the public, which often is blurred when we read the academic journals. So we have that issue as well. And the last project I'll mention that my students did about 3-4 years ago was looking at linked open data and 3D models on the DB Wikipedia, so the database behind the Wikipedia. And we could create dynamic linked editing, etc. But we couldn't easily link between all the different sources and federated databases because there's no shared understanding outside of, say, Europeana and so forth. But there is this option to build creative tools in there. So given what I've said about the different interpretations possible, about community participation, about immersive real-time dynamic editing, I suggest, and I won't have time to mention about FAIR and CARE, but that was part of the ECOMOS Digital Heritage Scientific Symposium we just ran last year in Sydney. We need to better integrate Paradata, however it's defined, and I'm going to suggest again, maybe it needs to be defined in 2 or 3 different ways. Design data, how they design from the collections and the LiDAR or photogrammetry material of historic sources, and civic data, how people use that to make decision making and a shared understanding from. It has to be accessible, as said before, it has to be useful, does what it says and provides for needs. It also has to be for the academics to be reviewable, measurably reviewable after publication, and how can we collectively reuse it. So I'm going to suggest as a very simple suggestion, surveying groups on concrete projects with actual audiences from different disciplines. And almost all the survey and evaluation data in virtual heritage projects, for example, have been a single audience giving a fixed process, representing a single discipline and not sharing it. So that's my suggestion. I'd be happy to talk afterwards, but it's getting a bit late at night. So back to you. Thank you for inviting me.
Thank you very much, Eric. Well done. Eric, I have just only to add something because your presentation came directly after the presentation of the different institutions of UN and UNESCO. How do we define a monument of the value of, or having a value of outstanding, yeah, and universal level? And it's a challenge. We are now at the digital transition, yeah. Nevertheless, the cultural heritage is the last area where ICT is coming in. We are in a transition time period. By saying this, we move to the next one presenter, and we move from Australia to New York, to USA. We have with us Carla and Mark, 2 old friends. Hi, good morning on your side.
Good morning, Marinos.
Floor is yours.
Thank you. So first of all, I'd like to thank my colleague Carla for all her help in putting everything together. And we're here to talk about reusable and reliable complex digital representations, including 3D, but not limited to it. And we're going to discuss a new piece of software that we've created in collaboration with our European partners and countrymen of Marinos's over in Crete in the Center for Cultural Informatics. Now, this is real software. You can go to our website right now and download it. It's called the Digital Lab Notebook. That's the link. Again, CHI, Cultural Heritage Imaging, which is a nonprofit corporation, partnered with the Center for Cultural Informatics, which is part of the Institute of Computer Science for the Foundation and Research, for Research and Technology, HELLAS. And we were funded by the National Park Service of the United States, the Institute of Museum and Library Services, the National Science Foundation, and finally, the National Endowment for the Humanities. So, what does a digital lab notebook do? It dramatically simplifies scientific imaging. And we're going to see that there's an essential relationship between some of the components of scientific imaging and what's called Paradata. What the digital lab notebook does is collect and manage meta and Paradata about a digital representation during its full process of creation, from the capture of the original scientific data, right? The context of the capture, the subject, the equipment used, the lighting, the vested interests of its participants, locations, people involved. Again, people with interests like funders or copyright holders or people doing the work, and of course, documents. We can also deal completely step-by-step recording the process which is applied to this captured information. And finally, the digital lab notebook software wraps all of this information up: the original data, the metadata, the Paradata, and the final work projects into submission information packages ready for archival submission to a long-term preservation environment. But let's just take a quick second and look at the basic essentials of the scientific method, because I think it allows us to simplify our understanding of Paradata. When you scrape away all the stuff that's unnecessary when we talk about science, there are two components that remain. First, that we are collecting observations of data from our senses, right? That means that two or more people must be able, in theory, to see the same thing. We can use cameras to extend our senses, microphones, etc. More importantly, whatever we collect as data, we have to write down what the context of that data collection was, the equipment, how it was done, etc. And then we have to record everything we do to that basic data to come to our conclusion, whatever algorithms are implied, whatever processing steps, etc. So the lab notebook essentially contains what we're talking about as Paradata. So what a good lab notebook allows science to do is allows the scientific work to speak for itself and allow people to interpret it according to quality. It enables reuse for new science, for new purposes, and it democratizes the scientific activity because it fosters distributed community science and separates scientific quality and scientific work from the authority of institutions, political and governmental agencies, and religious authority, and has done so more or less effectively for the last 400 years. What the digital lab notebook software does is it's an extension of a traditional scientific lab notebook into the digital documentary world. And so what it's doing is tracking all of the things that go into the building of a digital representation, and certainly complex digital representations. The DLN creates an account of how the empirical data was captured, whether through photogrammetry or multispectral imaging, and how the data was used then to make the digital representation of the world, which includes its processing history. Now, building good lab notebook accounts for complex digital representations is hard to do, and the DLN software simplifies this process to make digital representations transparent and reliable. The DLN fundamentally right now is scaled and built for recording digital representations built with computational photography. And that includes all the photogrammetry processes and related activities, multispectral and hyperspectral images, reflectance transformation imaging, multi-light imaging, and a variety of documentary photography methods, which include single photos, photo sets, panos, object movies, focal stacking, de-stretch for cave art, stitching, the whole thing. These tools are widely available computational photography tools, which means that a lot of people can go out there and document cultural heritage. And computational photography is also the class of technologies that's easiest to scale up, because with the catastrophes on the way, we need as many people out there documenting heritage as we can imagine. So what the digital lab notebook allows us to do is allow the digital representation and the qualitative evaluation of that digital representation to speak for itself. It enables reuse of digital representations for novel purposes, which means that if a group or a society invests in the digitation of cultural heritage, they will be paid investments over and over again in the form of reuse of these representations to develop new knowledge. Second of all, it democratizes the source of cultural heritage documentation, and this enables us to foster distributed generation of digital representations, and it allows people from indigenous communities and other cultural communities to be the source of digital representations, not simply the consumers. And this essentially separates the evaluation of digital representation quality from institutional, political, and religious authority, just like the scientific method. And anyone with the skills to collect photographic documentation can contribute then to the world's store of knowledge. And so it's really important that cultural communities and the people in the global South become documentation providers. And a good digital lab notebook, a good Paradata practice subverts digital colonialism and authoritarianism. It allows local communities and local values to control what's documented and what's shared. And this speaks directly to the Porto Santo Charter from 2021, calling for digital citizenship and the empowerment of communities in Europe. So let's take a quick look at the design principles of the DLN. It's open source. It uses only natural language at a user interface level. It's internationalized for simple translation to other languages, and you can enter as much or as little data as you see fit. The DLN stores information in a private database that can only be accessed through the DLN, and that database makes it easy to reuse the data that you've entered. And this also allows us to enter most of the metadata and paradata in advance of our imaging session. Stuff about equipment, stuff about processing, stuff about location, stuff about subjects we're going to be dealing with, documents that are relevant, and so forth, all can be entered before the first photograph is taken. Now, This means that frequently used capture equipment can be grouped into subassemblies, and when you get out into the field, you can very quickly say, this is the equipment we're using in this capture situation, and all that Paradata goes directly into the DLN. It also means that we can specify what the processing steps are as we're building our 3D models, and we can just click on workflows that we've previously entered when we're doing what we planned, and also to quickly change what we're doing if we skip and introduce a new process. Now, the most important thing is the DLN automatically maps all this collected Paradata from the digital lab notebook to the SciDoc CRM, and it does it in this way. The DLN uses an internal data model to represent all the information that we've brought in using ordinary language, and that's expressed in XML. This XML information is then transformed into the CRM and other metadata forms with mapping tools developed at the Center for Cultural Informatics, X3ML and the Transformer, and that's spectacular stuff. So the DLN can use the tools made by the Center for Cultural Informatics to map its records to virtually any metadata format. So if there's an updated Europeana format with a short investment in time and money, the DLN could speak directly to that format. Also, the DLN produces metadata as human-readable HTML output that can be just seen in a browser, and all this stuff can come up. And then it currently kicks it out in 3 other machine-readable formats: CRM mapped linked open data, Dublin Core stored as linked open data as RDF, which North Americans want, and Lido, lightweight information describing objects stored as XML. And as I mentioned, we can extend this to cover any desired format. And finally, the DLN wraps up all of this information, the captured original data, the metadata, and all of the subsequent work products, meta and Paradata, all the subsequent work products, into standard-based submission information packages. And these can come in the form of METS, Metadata Encoding and Transmission Standard, that I know the European Commission uses, or in BAGIT, which is a very nice submission information format developed by the Smithsonian. So the data is ready for archival deposit at the end of the day, and that's what the Digital Lab Notebook does. And thank you very much for listening to us.
Thank you very much, Mark and Carla. Very, very nice presentation. And of course, congratulations for your software and the work that you are doing.
Thank you, Marinos.
We do hope that the day will come that we give value to the 3D geometrical data sets which we are creating, yeah, as a result of the digitization of the past. And now from New York, we are moving to Belgium, to our colleague Daniel Blendix. Daniel, if you can share your presentation, please.
Yes, I'm here.
Daniel,
hello, everybody. Hello. Do you hear me?
As a coincidence, the same year, the same event when we met almost 20 years ago with Carla and Mark, yeah, we met too. Thank you very, very much, Daniel. Floor is yours.
Is it sharing?
Yes, we can hear you. We can see your presentation. And if you can go to the presentation mode, because you are in the, yes.
Okay, here we are.
Yes, here we are, yes.
Okay, good. Right, so thank you very much for inviting me. And I wanted to talk today about 3D heritage and more specifically about virtual reconstructions. And why is that? Because in fact, if we are preserving today heritage, and if we are digitizing that preserved heritage, we need to understand that in fact, what we preserve, in fact, is only 1 promille, let's say, of what has existed, what the world was in the past. So that means, in fact, that most of what we try to digitize today is only a small representation of the whole virtual world that is the past. So that means that, in fact, we are missing a lot. We are missing also the things that are damaged. If we excavate something that normally doesn't come out of the earth in a pristine form. In most cases, it's broken, it's partial, etc. So we need other techniques to make sense of those objects, like digital restoration or virtual reconstruction. And of course, to all those tangible objects that we try to preserve, in fact, we have a lot of intangible heritage that is linked, which is not only stories, but also the context, biographies of people. How are the objects used? What are their meaning? What is their social context? So there is a lot of extra data, in fact, which is linked to those objects. And that is indeed also the knowledge that the researchers try to find, in fact, that the teams that work on this digital heritage try to find out, and together with experts, in fact, try to make sense of what we find back, try to understand, try to put them in context. So that means, in fact, that when we are preserving 3D heritage, we can say, okay, most of the objects that are fine, that are, let's say, 80% complete, we can just copy them like they are. And that's what we mostly talk about when we are talking about digital heritage today. So we are scanning them, we are doing photogrammetry on them, or any other technique that digitize them in 3D. But many other objects, in fact, do need digital restoration to show them how they were. And you see on the right, in fact, an example of one object that we did. You see in the back, in fact, the original object that has been excavated, and you see in the front, on the top image, the digital restoration that we have made, and you see it more in detail in the bottom image. It's not just making some nice pictures. There were more than 2 full months of study behind this digital restoration. So that means, in fact, that digital restoration goes together with interpretation of what we have. What is the meaning of the object? What is typically in that age? How old is the object? Etc., etc. And dealing with all that uncertainty, coming, in fact, to a virtual reconstruction of the object like it probably has been in the past. So that that is exactly what digital restoration is doing. And when we have, for example, a ruin of a castle, which is 20% of the original castle, let's say, then we can try to reconstruct that castle how it was. And again, find other sources, find descriptions, find drawings, and try to puzzle them together and try to limit, in fact, the uncertainty and try to come up with hypotheses of, okay, this is the real, so this should be the real castle, how it has been. So all this process data, in fact, how we do understand these objects, what is the context of these objects, and so on, that is, in fact, to me, what is the Paradata. The Paradata is, let's say, the glue, that links all the different parts and the different sources of the object and makes meaning out of the object. And that is exactly like you call very correctly, Marinos, a memory twin. And it's much more than only the object, that there is interdisciplinary knowledge, in fact, that we need to put together. There is intangible heritage linked to the object. All that, in fact, is the memory twin, is the digital twin, but as a container of not only the 3D object, but as much more, as the data, as the metadata, as the paradata as describer, in fact, of the process of understanding the object, of reconstructing the object, of digital restoring the object. So virtual reconstruction is something that is very much linked to Paradata. And so that Paradata, in fact, is put into a synthesis, in fact, of all the available knowledge on a cultural heritage object. What do we know about this typical object? You see, again, the same object here, but the top image is the scan, the 3D scan of this object. And the bottom image is then the use in a gamification project. But we need much more context data to be able to put it in such a gamification. So that context information, that is what we need to store, in fact, and to obtain, to digest, to put together, and then to store as paradata of this object. And that process, Paradata is process data, and that process is a very multidisciplinary and scientific process. And basically it doesn't need to be 3D. You can do virtual reconstruction not in 3D like many archaeological and historical illustrators have done with 2D drawings. But today, with the means we have today, I think it is much, much better that we can really do this in a very flexible and reusable way, like Harry has said, in 3D. So I think 3D is really the preferred way of dealing with virtual reconstruction. And exactly the recording of that complex process, putting all the resources together, understanding them, puzzling them together, and coming with some sound hypotheses, in fact, of what the object is, what it means, how it is used. In fact, that is exactly what, for me, is Paradata. So this multidisciplinary process, in fact, is something which is tedious, complex, it takes a long time, it can go on for many, many years. Most of the stuff that I am showing you, in fact, has been excavated in the 80s and the 90s. We're 30 years later, we're 40 years later. So this is a process that goes on for quite a time and will continue also. The people that come behind us, in fact, that come after us, will also further use that. So we need to make sure that, in fact, this knowledge can be preserved, because, in fact, we need to see it this way. We preserve cultural heritage and cultural heritage objects because they are unique, they're unreplaceable. Well, in fact, that knowledge in most cases also is. So we need really to treat it in the same way. We need to take really care of that data, although it's digital data, although it's intangible stuff, but nevertheless, that knowledge, that work, in fact, that know-how of people, in fact, that needs to be also seen as unreplaceable, and that because it comes from people that are available, people that are still there, that are still living, temporary cooperation with experts that you don't have tomorrow anymore, teams that are working together but not working together anymore tomorrow. So that means, in fact, that all these things need to be seen as valuable and something that we need really to preserve with the same care as we do with real objects. And it also goes for the storytelling, for the objects connected to those objects, to the social context that other people, for example, other experts have derived. So that means, in fact, that we need to find ways to put this data, to put this virtual reconstruction data, this Paradata, in a central database. And in fact, what we should do is funding, when we give funding to make this kind of virtual reconstructions, we should put as a requirement that this Paradata and metadata and data, of course, that they are all stored. That should be the requirement for the funding. Oops. Yes. So one of the ways to do that is what is coming up, in fact, now from the European Commission. The European Commission has started the process of making a European collaborative cloud. And the European collaborative cloud is, in fact, a way to collaborate between experts, create data, metadata, but in fact, do the process and document that process. And that means creating the Paradata for the reconstruction, for example, that has been made. It is a collaboration for experts within a cloud that is documented and that is supported and stored. And that is linked, of course, to the data space for cultural heritage, where Europeana is very much involved in, and also in the European Collaborative Cloud. In both projects, Europeana is involved. And in fact, it's about storing that data, storing not only the metadata and the Paradata, but also making it accessible, like we have said already in the previous presentations, for all types of users. I think it is important to find, of course, specific ways to address the typical layman user, the typical expert user, the typical student, etc., that they can use this kind of data. Let me give you an example, in fact, and that is the word ENAM has already been put a couple of times, and ENAM is a site that has been many, many years already in the picture of doing virtual and digital cultural heritage, in fact, but it is a small village, and in fact it is a failed medieval city, and it has been one of the biggest cultural heritage projects in Belgium. And in central in the village is in fact a parish church, and in parish church dedicated to a typical Italian saint, Saint Laurentius. And everybody was thinking, oh, this is a 12th century church. The church, no, it isn't. So the detailed research has showed in the 90s that it was built around the year 1000. We even know much more precise for the whole story of the building and so on, but I won't tell that now. I don't have the time. But there was, in fact, full research in 1993 revealing Byzantine wall paintings. There has been a full excavation and a full restoration in the period around 2000. And that means, in fact, that this very unique church, which has been preserved by accident. Most of the churches have existed in Europe, but they are all gone because they're mostly in towns, and they were destroyed and replaced by more modern Gothic, whatever, churches. But here we have an Ottonian church in an Ottonian border town, and which was part of an imperial program. And basically it has been built by Emperor Otto III when he was 16 in 96. And so this story we have also completely be able, together with other experts, of course, like Dirk Calabot, who has been working on this site for more than 30, 40 years. Altogether, we in fact have found out that these wall paintings have a wider context, in fact. They are not only the oldest wall paintings in the Low Countries, but on the other hand, they keep, in fact, a secret of a failed imperial coronation. Otto III died when he was 21. And so it has been used also for another imperial coronation by the next emperor, Henry II, in 1020. So there is a lot to tell, in fact, about this church. And that means, in fact, that it is an enormous pity that up till now, all this research and all this excavation and so on have not been published yet, not in depth. There have been some articles about it, but not in depth. And in fact, the exploitation at this moment is done at the provincial level, but they are exploiting the archaeological side, but they don't care about the church. So the team that has excavated all this has disappeared. All the knowledge, in fact, today sits in the head of 3 people that are 60 plus. And that means, in fact, we have such a unique case. In fact, we have such a unique site of European value with links to Byzantine, to all kinds of things and so on. There is basically no financial support to do something with that. So we have done a lot of work on that, but most of that on our own cost, in fact. So that means, in fact, that this church, for example, to be the data of that reconstruction of the digital twin that we have made to be usable, in fact, we need to produce the data. We have done that. We need to produce the metadata. And we have produced all the paradata. Virtual reconstruction is our main business, so that means we produce paradata on nearly daily basis, in fact. So that means, in fact, that all this context information, the interpretation, the storytelling, in fact, all has been produced from this church. And we are eager, in fact, to store this and make sure that this is not only stored in databases, that this is published and so on, but that this also can be further used by other researchers, because this is really a unique church which is endangered. Most people, when we talk about endangered monuments, they are thinking about crumbling walls and so on. This is, in fact, also endangered. And that means, in fact, that I missed a slide. Oh, okay. That, in fact, there are some silent killers, in fact. Where is my... here. There are some silent killers, in fact, and that silent killers are, in fact, of cultural heritage are, in fact, that teams can dissolve easily. Experts are not there anymore tomorrow. Research data is not always perfect. So if you pass it on to the next generation, do they really understand what you have written down, what you have documented? So maybe you still need people to understand that data. If they're gone, a lot of knowledge is gone. Yes, thank you. And I'm finishing. And so that means, in fact, that there need also to be political interest, like I have shown, in fact, and we see that declining today. And we see a declining interest in history and archaeology. Nearly every month, some archaeological department, some museum is closing in Europe. And that is quite important. We need to make sure that cultural heritage becomes relevant for society. To give you the example of a program that has been made here in Flanders, the story of Flanders, which was showing, in fact, the history of Flanders as a scientific program. It has drawn, in fact, in 10 programs, in fact, in a series of 10 times 1 hour programs, it has drawn 25% of the Flemish population because of the storytelling. And that is so important, in fact, to make sure that this information can be also shown to the public. And that is also what we have done, for example, when we make these kind of virtual reconstructions, as you see in the images, we also put in the sources. We put it in as a kind of 3D PowerPoint, and you can bring up the sources when you're near that ship that you see there. In fact, you can bring up the sources for that ship. That means that somebody who is using the virtual reconstruction can tell the story. We hope that these presentations are distributed, so click the links and then you will see some movies, in fact, that show all these things in detail. So thank you very much for your attention.
Thank you, Daniel. Up to the point, your presentation, and yes, indeed, it's extremely important to keep a correct record for the 3D geometrical structure. And now from Belgium, we are moving down to Malta, the smallest member state in the EU, and to our colleague, Tony Casa. Tony is working for the Heritage Malta, and he is the person in charge for the digitization of Malta's memory. Tony, floor is yours, and thank you very much for sharing your presentation. Tony, we cannot hear you. We can see your presentation. Yes, now we can hear you. We can see your presentation.
Good.
If you can go to the, yes, presentation mode. Thank you.
Yeah, okay.
Floor is yours.
So thank you, Marinos. As you introduced me, I am responsible for the digitization unit of Heritage Malta. Heritage Malta is the national agency for cultural heritage in Malta, and we are responsible for more than 90 sites, including museums, sites which are underground, over land, underwater, as well as the contents of these sites, millions of artifacts, as well as intangible cultural heritage, which are the memories, the intangible part of our history. So as a national agency, this short presentation is from the user point of view. I found the previous presentation extremely interesting and useful, especially the one about the digital lab notebook. I've already communicated to my team that I downloaded it, and we plan on using it on scanning of a UNESCO heritage site in Malta. So I'm sure I'll let you know how it goes. What I'm going to speak about is from a user point of view, as the user, as the consumer of 3D cultural heritage, what challenges we face when we come to scan in 3D cultural heritage. So as an agency, like most agencies, we use different forms of capturing data, capturing 3D. One of the most popular would be the drone photogrammetry, especially when it comes to very big sites where we need to do relatively quick and accurate 3D scanning of sites. We obviously use LiDAR scanning for terrestrial scanning. We use photogrammetry a lot, both for sites as well as for individual artifacts. Handheld scanning, which we use for artifacts, and RTI. So these different types of digital acquisition are all being used to answer one basic question, which might sound simple. Why do we scan in 3D? What is the purpose of doing all this effort? In the beginning, Harry mentioned this direction of 3D on a European level, the need to digitize more our cultural heritage in 3D. But very often we end up asking ourselves, why are we scanning? Why are we moving towards scanning in 3D our cultural heritage? And when preparing for this presentation, I had an interesting discussion with members of my team, and we came up with a number of use cases why we scan in 3D. And based on this, then I'll finally move to the challenges we face when scanning in 3D. So I'll quickly share with you some of the reasons why we scan in 3D. The first of which is obviously documentation and conservation. So when we speak about documentation, it's because we have artifacts which need to be recorded as accurately as possible. We need to know the current state before a restoration, before any intervention is done. Obviously, we have requests coming in all the time from the conservation departments who want us to do scans of artifacts, of sites, of buildings. So over there, we have to use different digitization technologies and methodologies to scan and create the 3D models of the items themselves. And obviously, whatever has been said about metadata and paradata and these kind of projects applies to every one of these use cases that we're doing. So apart from documentation and conservation, we have the need to document sites to create heritage bins. So as I said in the beginning, we have sites which are we have many sites which are under the responsibility of the national agency. And over here, these sites are being restored, they're being improved, they're being reused, reinterpreted, changed into museums, being opened up for visitor centers. And we need to understand the building. So through these 3D heritage BIM structures, which we're creating, we're bringing in different users from maintenance, the electricians, the curators, the conservators, to all understand these buildings and use these 3D models as the working documents for any interventions that they will be doing on site. Everything is geolocated, everything is referenced, everything is linked with a lot of data, whether it's data related to the artifacts, whether it's data related to interventions being done on the site. So yes, this is another way how we use 3D scanning of cultural heritage. Obviously, as the national agency responsible for the national heritage in Malta, we run very strong outreach programs, because in the end, that is one of the main pillars why we are set up. So whilst we are there to conserve and protect and document our heritage, we're also there to make sure that this heritage is reaching the public out there, whether it's local or international public. And we also have issues of accessibility with some of our sites. For example, over here we have this two photos, one of which is around Malta. We have a lot of underwater heritage sites. In fact, one of the advantages that we have is that in a very small area, Malta is literally studded with lots of different shipwrecks from different eras, ranging from Phoenician shipwrecks to World War II shipwrecks. And all of these, most of these are very often at a depth which is a bit prohibitive for normal divers, let alone people who do not dive. So over here, we are using 3D to make these sites accessible to the public by turning them into VR experiences, by turning them into by using digital tools to make them accessible to the general public. And I have to say, this is one of the most interesting and successful ways of how we use 3D accessibility programs within the agency. We obviously are interested a lot in the creation of digital twins. A lot has been said about virtual twins, digital twins, virtual worlds, the metaverse, and we have been experimenting and playing around with these digital twins. In fact, as Harry said, we participated within the Twin It campaign. I'm happy to say we were the first to submit our digital model as a country. We submitted the digital model of a whole site. Over here, we have another heritage site, which was built by the Knights of St. John, but then later on turned into a major British fortification in the Grand Harbour of Malta. Obviously, when we say we're creating a 3D model, we don't just stop at the overall scan of the model. Then we have to go into layers. We go into the building. We go into what's displayed inside. We link this to the collections management system and show the individual artifacts which are being displayed, the narratives which are being told here. So here we're using digital twins to create a new form of virtual museums, something which is much more engaging with the public. For us, the visitor engagement is extremely, extremely important. So we are using these 3D digital models to improve creating virtual sites, virtual museums. obviously, we have a lot of exhibitions happening in our building. So one of the things we do is when we are planning exhibitions, we scan buildings where we are actually installing the exhibition and planning the exhibitions itself. So yes, we use 3D models to integrate them with the design teams of exhibitions, of the museums, and making sure that everything fits and works as one whole project. So this is also a very practical way of why we scan. And just quickly, then there is the commercialization of 3D, and this is one particular aspect which is quite interesting and complex when it comes to 3D modeling. As one of the speakers mentioned before, 3D scanning, 3D modeling is not just a static process. It involves code, it involves very dynamic processes, and over there you start getting issues of IP, of copyright, of who owns the 3D process, which is quite complex and quite a challenging aspect when it comes to making 3D objects completely openly available. Because museums also use 3D objects to help create income for themselves. So we've created 3D models which were used in some major blockbuster films which were shot in Malta. So this is also a form of income which we use to sustain the income of the agency in becoming sustainable. So we have to find a balance in those kind of, that's one of the reasons why we also scan in 3D. So once we've seen these reasons why, I'd like to finally close with 3 particular challenges. There are many other challenges, but I'll just touch on 3 challenges which we face when digitizing cultural heritage in 3D. First of all, there's the technological challenge. Over here, we have a very fast process of changes in the availability of hardware which we use. We have very different scanning techniques, and finding the right technique, joining different types of techniques is a challenge. There is also a challenge of education when it comes to the other departments, the other experts who request digitization. Very often we find that we need to collaborate together to find a way which meets their needs, which might not be the original request. So sometimes we get a request for a laser scan of a particular object, where a photogrammetry scan would work better. Nowadays, we're experimenting a lot and we're using a lot of hybrid ways of joining different types of digitization acquisition methods and joining them together into one scanning technique. And these create challenges because it's very difficult sometimes to create very strict methodologies when the underlying technology is changing all the time, both relating to hardware, but also relating to the software systems that are used in acquiring this data and rendering the 3D itself. Another challenge, which I've mentioned before, is this fluidity. The fluidity between the different types of hardware and software, but also coming from the different types of requests that we receive for what the end use is coming for, what to use the end product. And this means that sometimes we have challenges as to in what resolution, how complicated should we do it? We have to find a balance sometimes, and the balance does not mean that it's always the right decision that we take. The final balance is, the final challenge is finally that we need to find a balance between funding and use. We are a public funded agency and we have very specific missions that we need to carry out. And sometimes finding the balance between how many objects should you scan in 3D if you had to scan everything in the highest level of detail and providing very detailed paradata towards it. So we need to find this balance between making the best use of the funding which we are receiving and at the same time making sure that this 3D scanning that we're doing meets also the objectives of the agency. So very often it's a balancing act between what we set up what our national obligations are, what our funding is, what is the best output in the shortest possible time. So finding a balance is sometimes a challenge in itself. I think that 3D scanning of cultural heritage is the way forward. It's what Heritage Malta is investing a lot of time and effort and money, but it's definitely a learning curve. The need for standards, the need to integrate this in our collections, in the decision making, in the way the curators, the conservators, the different experience development managers that we have, the exhibition designers, the outreach programs, how are all the needs of these different users making use of the 3D products that we are creating? Because we need to make sure that what we are creating meets the needs of the widest audience requirements, but at the same time meets a balance. One of the first things that Harry mentioned in the very opening introduction was this agreement that on European level, we need to scan in 3D all the cultural heritage at risk in Europe. This is a very ambitious and good to have objective, but the reality is that we have many very limited resources, both in terms of capital, both in terms of human resources. So again, even there, we need to find a balance. We need to prioritize. We need to find the right methodologies in doing that. And when you speak about the right methodologies, there's no one size fits all. We have to also understand that being too simplistic, being too generic is sometimes not the best way forward. So basically, that's my short presentation. I hope I gave a touch of the daily challenges that we face as an end client, as an agency who is committed in 3D scanning and 3D digitizing our national cultural heritage. Thank you.
Thank you very much, Anthony. Yeah, that's a message coming from a person in charge of the digitization of the past and how important it is. Very good presentation, Tony. Thanks. We had now to move to the next presentation and from Malta to fly to US. Unfortunately, our colleague Shui Yin is in bed, is sick. Apologize, and we are going to have the speaker in our second webinar. As you may know, we plan to have a very short webinar, 3 hours long, one time and finish. We went out for a call of abstracts and, of course, speakers. And at the end, we received
Marinos, you are muted.
Sorry. Thank you very much, Anthony, for the nice presentation. We had now to move to USA, but the colleague is unfortunately ill and cannot give a presentation. We don't have a video to present. Nevertheless, we are going to have the colleague during the next webinar. As you may know, a month ago, we went out with a call of abstracts, and instead to get, let's say, up to 10 abstracts, we got 50 plus abstracts with excellent colleagues actively involved in this way from around the world. And this is what we decided at the end of the day is to create a series of events. That's the first one today. The second is going to be on the 17th of May, the day before the International Day dedicated on museums, which this year, coincidentally, is dedicated in education and research. in the domain of museums knowledge. Now, due to the fact that we have some time, we shift this free time of few minutes to the end to have more discussion. And we go to our next speaker. So from Malta, instead to go to US, we go to France, Jean-Baptiste Barrault, an archaeologist, who is going to give us his presentation. Jean-Baptiste, you are online? Yes, and thank you very much, Jean. So we can see you. If you can share your presentation, please. Now we can see your presentation. If you can go to the presentation mode. Thank you.
Jean-Baptiste Barrault, and I am an engineer at the French National Centre for Scientific Research, CNRS, in Nantes, located in western France. Additionally, I am an associate member at the Archaeology of the Americas Laboratory, ARCHAM.
Jean, if we can go to the presentation mode, please.
Please excuse me for using a synthetic.
You were in the development mode. You had just only to activate the presentation one mode. Drew, can we share the present? Oh. Yes, excellent. Thank you.
Laboratory, ARCHAM, UMR 8096 in Paris. Please excuse me for using a synthetic voice as I have lost my voice this weekend and I also suffer from a congenital neuromuscular disorder. Today, I will be giving a brief presentation entitled Three-Dimensional Reconstruction of an Egyptian Sekiya, a computational approach to preserving cultural heritage and water management systems. Thomas Subira's thesis draws attention to the technological and technical disparities between Andalusian/Moroccan Sekiyas and their Egyptian counterparts. While the former typically consists of two wheels, the latter is characterized by the presence of two vertical wheels along with a horizontal one. Furthermore, a technical investigation conducted by Manassa and Laferriere in 1974
we cannot see your presentation. We see just only the first slide. But if you want, we can share your presentation from here so that we can help you. And we can try to, you know, according to the, yeah? Okay. Thank you. We will do it from here. We share your presentation from here. Thank you, yeah? And get well soon, yeah? All the best.
Specifically within the Gorna region. Historically, these Sekiyas played a crucial role in supplementing natural river irrigation during periods of low water, with their operation being halted during Nile flooding, a practice that persisted until the construction of the Aswan Dam. The mechanics of Sequoia operation are detailed, elucidating its capability to lift water to heights ranging from 10 to 11 meters, necessitating well depths of 14 to 15 meters. Comprehensive descriptions encompass the construction of wells as well as the intricacies of wheel and gear operation. In the water distribution system, water is lifted and directed into a wooden basin that connects to a canal, leading to the primary irrigation channel. From there, secondary channels disperse water into rectangular basins, effectively partitioning the land into rows for irrigation. In the flood irrigation method, water is transferred from upper basins to lower sequoias through small earthen dams. Hay walls, agricultural workers, oversee the distribution of water to ensure equitable irrigation across all plots. Due to the high costs involved, multiple families typically own sequoias, each capable of irrigating 5 fedans, with continuous operation nearly covering 1 fedan. A yield of 10 to 12 rdap of wheat or corn per fedan is common. Despite their prevalence until the 1970s, sequoias have largely been supplanted by diesel pumps in modern times. In the studies conducted by Manassa and Laferriere, comprehensive 2D blueprints were meticulously crafted, offering detailed insights into the operational mechanisms of the sequoia irrigation system. These blueprints, along with the entirety of the published data, underwent thorough examination by archaeologists in 2018. Including detailed descriptions of the excavation process and data collection methods, Paradata. Additionally, a plethora of drawn representations and diverse photographic documentation of similar sequoia components have been amassed, reflecting the widespread utilization of these systems across the African continent. These images serve as invaluable resources and facilitators for endeavors aimed at 3D modeling, enriching our understanding. Blender 3.0.1, the open source software renowned for its versatility in 3D design, played a pivotal role in the creation of various elements within the project. To expedite the process, existing free models depicting branches were skillfully modified and tailored to suit specific requirements. Meanwhile, the creation of ground stones involved a meticulous transformation from initial 2D drawings into 3-dimensional entities through a series of intricate techniques, including extrusion, beveling, subdivision, and decimation, facilitated by the application of various modifiers within the Blender interface. Moreover, the inclusion of an emaciated bovine model added depth to the composition, sourced from freely accessible and royalty-free assets found on the Internet, underscoring the project's commitment to utilizing open resources in its development journey. The goal was to achieve a toon-style rendering that strikes a balance between the time spent creating materials and the clarity of the final result. A sun lamp was strategically placed with a strength of 5 to illuminate the scene effectively. Rendering settings were kept to standard view transformation. Materials were carefully crafted, incorporating elements such as a diffuse BSDF, a shader to RGB conversion, a color gradient with consistent interpolation, and the use of 2 distinct colors, one for the primary hue and another for creating shadow effects. Produced using the Eevee rendering engine, Blender's real-time rendering tool, known for its swift performance and interactive features. The 3D renderings exhibit good qualities. EV, constructed upon OpenGL, emphasizes quick rendering and interactivity, all the while maintaining adherence to physically based rendering, PBR, principles to achieve lifelike material representation. However, within the Sekia scene, specific elements are lacking, particularly concerning the user's viewpoint positioned behind the bovine object. Utilizing ALTAG 3D for long-term archival of data and metadata related to the 3D model of an Egyptian Sekia offers a compelling solution for various reasons. Firstly, it aligns with the FAIR principles, ensuring data and metadata are findable, accessible, interoperable, and reusable, thus promoting longevity and accessibility. Collaboration with CEST, a renowned institution for research data infrastructure, ensures robustness and reliability through the Open Archival Information System, OAIS. A new tailored metadata schema enhances content description for humanities research, fostering inclusivity. Integration with standard vocabularies and mapping to the European Data Model, EDM, improves interoperability. Features like a 3D viewer enhance utility for researchers and the public, fostering engagement. ALTAG 3D's desktop UI software's adaptability to the new metadata schema ensures practicality and effectiveness in generating submission information packages, SIPs. In summary, ALTAG 3D provides a standardized, user-friendly solution that meets the evolving needs of humanities research, promoting accessibility and preservation of 3D data and metadata. Implicit knowledge and explicit reasoning surrounding the 3D reconstruction of the Egyptian Sekia encompasses various facets. Geographical localization entails meticulous mapping of the surrounding terrain, including watercourses and irrigated fields. Understanding the technology and mechanism involves delving into the operational methods of the Sekia, whether it be mechanical or animal-powered, as well as identifying the type of lifting system employed, such as rope and bucket or bucket wheel, alongside precise measurements of the water lifting and distribution mechanisms. Historical context sheds light on the Sekia's dating and presumed use, as well as its significance within the region's historical framework, encompassing its societal role and cultural implications. Analyzing environmental and social impacts involves assessing the Sekia's influence on local water resources, biodiversity, and surrounding ecosystems, as well as its social and economic contributions to the local community. Ethnographic and cultural data encompass narratives and testimonials from residents regarding the Sekia's history and usage, as well as cultural practices associated with traditional irrigation systems. Comparative analysis further enriches the reconstruction by juxtaposing it with similar NORIA or water distribution systems regionally and globally, providing valuable insights into its technological evolution and cultural context. Financial obstacles pose a significant challenge to 3D digitization and reconstruction initiatives pursued by African research entities and businesses. Particularly in certain African regions, insufficient technological infrastructure, including high-performance computers and reliable internet connectivity, presents hurdles in implementing advanced digitization endeavors. Overcoming these financial barriers necessitates increased support from governmental and political entities. Advocating for the significance of digitally preserving African archaeological heritage among policymakers could spur greater investments in this domain. On the flip side, the use of Blender, being a freely available software, obviates the need for financial resources for African organizations engaged in 3D reconstruction endeavors. Additionally, access to photographic and graphic documentation of archaeological structures, some of which have recently existed in Africa, empowers viewers of the 3D models to form their own conclusions regarding the accuracy and relevance of the reconstruction efforts. I appreciate your attention and understanding. Once more, I apologize for the inconvenience caused by my current inability to speak and the use of this synthesized voice. However, please know that I am fully accessible for any further communication or discussion via email at jean-baptiste.bureau@cnrs.fr. Thank you for your patience and cooperation.
Thank you very much, Jean-Baptiste, for the excellent presentation. Here is a milestone one, yeah? Is it a 3D reconstruction which we are going to do, or is it a knowledge reconstruction by using 3D, reverse engineering, the way of how you presented it? Very nice, very well. Thank you very, very much, yeah? We do hope to see you soon in Cyprus, yeah? Still remember when you visited us once. Thank you very, very much. Excellent work. Congratulations. And from France, we go now back to Netherlands, to Europeana, to Anthony Isaac. Anthony, you are online? Yes, I see you.
Yeah.
Thank you very, very much for sharing your presentation. Floor is yours. And yes, one of the greatest challenges at the beginning of the 21st century, after 15 years of running the business of Europeana, here we are. We are moving probably from Europeana to the Library of Alexandria, yeah? Let's see. Digital transition, immersive, yeah, metaverse and all this. Let's see. Thank you very, very much, Anthony.
Thank you, Marinos. Thank you, Marinos. Checking, can you hear and see me? Because now I'm in presentation mode, so I'm a bit blind.
Yes, we can hear you. We can see your presentation, and even we can read it. Yes,
excellent. Yeah, so yeah, I'm not sure how to manage expectations that Marinos raised. I'm not going to talk about a lot of metaverse stuff, but it's going to be a bit down to earth considerations about data modeling. So first, I'm not alone in this presentation. I'm representing today a small group of Europeana initiative participants, which includes some data space supporting projects. And of course, we are all grateful for having been given the opportunity to be invited to this webinar today, as it is extremely important, as Harry Verweilen introduced it earlier today. This is something that is really dear to us at Europeana and in the data space. So a bit of context. So we are coming from an effort where 3D is becoming more and more important. The Common European Data Space for Cultural Heritage has begun work to drastically increase the amount of 3D that we make available. Harry has already presented the Twinit campaign, so I'm not going to say much more about it. But basically, we hope that this raises awareness and momentum. And this is not the only thing. So we have data space supporting projects that are creating and will ingest new 3D objects in Europeana. So we are very much counting on their crucial contributions. And there is a range of actions that are needed to make our infrastructure and services handle better 3D objects. So it's not just about raising awareness and digitizing new things, but also making sure that we can make justice to this new content in the core infrastructure and services. And because today's topic is about metadata and paradata, I must introduce the Europeana data model, or EDM for short. And I'm going to keep it really at the high level. So the main message is that it was collaboratively developed within the Europeana initiatives and some projects that prepared it. We follow the semantic web principles, which gives us the possibility to reuse some linked data resources, which is nice, especially with respect to the management of multilingual data. So on this slide, I've got here an example of one of the key resources of the data model, which is the provided cultural heritage object. And you can see some metadata fields like title, creator, descriptions, or type, which allows some representation of what the original object consists of. So the question that our group tried to address is whether the model as it exists now is good enough for 3D. So we have reviewed EDM in the light of high-level requirements and some concrete examples that we could gather from ongoing projects. And the first thing that I must point out is that we've seen on the previous slide the resource that's called provided CHO, which stands for the original object. And this is not the only key resource in the Europeana data model. Indeed, we also have another class called EDM web resource, which stands for digital representations, and that could include 3D models, as this example that I'm showing now, which comes from the Twinit campaign. So we've got a real object, so to say, that's the 30th century rotunda, and then we can have 3D models of it. And those things are being gathered into another class that we call aggregation, that we will use for from a model called OAI ORRE, and that's actually pretty much in the shape of a digital twin. We had some discussions recently where someone noted that an aggregation in the Europeana data model may be quite akin to the digital twin because it puts together an object and its digital representations. So we've looked at those things and we try to see how they can be used in the case of 3D. And the main observation is that the fact that the model has digital representation as fully fledged resources is very important. So it allows to represent cases where there would be, for a same object, a 3D model available. Like here, we've got a polished axe head coming from Ireland. So there's a 3D model, but there's also a 2D photo of it, and there could be some diagrams, etc. And the web resource class, it's good in the sense that it allows to represent things that can have different rights, that can have different formats, etc., or even, as shown here, really that are different types of representations. So we believe that those distinctions are still relevant for very diverse 3D content, from reality capture 3D models to both digital objects. We think they can be applied. And what's good is that, again, it allows a clear separation between the metadata that describes different resources. But essentially, this separation must be followed. So that's what is often referred to as the one-to-one principle, especially in the metadata communities like the Dublin Core one. So it's really about not mixing metadata about different resources onto the same container, so to say, which can create a lot of ambiguities and a lot of confusion for data reusers. So diving a bit into the metadata properties that are allowed for web resources, So those digital representations, I'm not going to list everything here, but essentially we can see that we are having a bit of support for what one could start to call paradata. So information about how the digital representation has been created, who has created it, and so on. The question is whether it's good enough again. And there, going beyond the main pattern with the three classes that I've shown, we started to dive into these metadata properties, especially for the web resources. And we started to see that there are some shortcomings. So, for example, there is a basic media type that guides the Europeana navigation system, which is not activated at the level of digital representation. So actually, this one would not really work very well to distinguish 2D representations for 3D ones. We also identified the need to represent types of model by high-level categorization. So whether something is captured from a real object in a sort of, well, a faithful way, or if it includes some 3D reconstruction, say by the work of some researcher that try to reproduce what the original object may have looked like. I mean, for example, things that, well, many presentations have previously shown, but I think Daniel's one was very strong on showing the distinction between what's digitized from reality and what research can produce in terms of enriched content. Then another categories of requirements that we are falling short in terms of modeling is the representation of the technical aspects of the representation. So whether we've got a point cloud, whether we've got a mesh, and so on. And finally, we also had some hints about it in the previous presentations. We missed some indications about the specific usage that 3D content may have been shared for. So for example, we've got 3D objects that are presented in viewers that are embeddable on other pages, which is very useful for, let's say, basic exploration. But we can also, of course, have versions that are fuller, such as the raw results of the digitization that are provided on some services. And of course, we would like to represent those things. And we are approaching more and more the Paradata issues here. We have the problem of identifying some metadata elements which would allow a more fine-grained characterization of 3D assets and their provenance. So we have observed that some fields that are activated for the real object, the original object, are not necessarily activated for the digital representation. So it doesn't have a title, for example, which is absolutely a problem in some cases. Even a simple field like dc-terms provenance is not activated for all the resources. So we are going to have a look at that and try to push those things higher on the data model, so to say. And in terms of Paradata, actually, I'm quite happy that we had some previous presentations trying to identify the trade-offs between representing everything that could be represented and trying to identify what can be mostly useful for users. Our plans is to identify a core of Paradata elements that would be included for support to essential services. And then we would offer to data reusers a sort of linking mechanism to give them access to the full Paradata that can be expressed in the relevant standards or more specific formats. The basic assumption here is that the Europeana website is rather a discovery platform that gives access to digital collections, and it's meant for various uses. And we're not sure that the Europeana website and the underlying services and then consequently the data model should need to cater for all the categories of Paradata that possibly exist. We certainly must make it accessible because, well, we're not going to dispute that it must be acquired during digitization. It's very useful. But maybe there's a bit of gradation between the core that should be embedded into the general discovery platform and the full version that certainly needs to be provided some form of access but for example, that may not necessarily need to be indexed together with the entire, with all the other categories of metadata. But of course, we must make a commitment that essential categories like digitization, methods, software used, texturing, etc., they must not be hidden in basic fields like description or provenance, and be mixed with other things in Europeana. They must show up as Paradata as such. And here I wanted to show an example of how things are happening currently with the model. So there's an item page which gives access to the 3D model for a stone axe. And there is some metadata about the item, I mean the original item from the Neolithic. And then down the item page, there's a bit of provenance, which is actually about the provenance of the 3D model and not of the stone axe itself. And of course, this is not ideal. We should really make sure that this Paradata is represented as such onto our services. So that's it for the metadata and the Paradata. So this is still work in progress. And I wanted to point that we also plan to have some support actions which are not only about the data model. The data model is only one part of the work needed. There are some actions required in terms of the documentation of the model, in terms of recommendation for delivering 3D content that is high quality enough. And of course, if we get higher quality data and metadata, and that includes Paradata, then we should make sure that the services that are developed by the data space are good enough in terms of the presentation it gives of this data, especially considering the user requirements. So again, we will have to make a selection of the user requirements that we serve, but we surely must be committed to provide a good presentation experience. And to conclude, actually, as part of the general work around 3D, we still have a survey that targets operator of data infrastructures for 3D heritage. And Marinos has very kindly contributed a QR code that I could stick next to my URL, which you may not have the time to type. If you want to contribute to this survey, the QR code is going to be up until Marinos tells me to give the end to the next presentation. And yeah, I'm going to thank you on behalf of all my colleagues and friends who are working on this. And if you have any feedback, any reaction, we'll happily take it in the chat or by direct contact. Please do not hesitate. Thank you very much.
Thank you very, very much, Anthony. You can keep your presentation running. The last 2-3 presentations, amazing. It's all about knowledge-based, 3-dimensional digitization of the past. And this is what I started thinking during your presentation, Anthony, in relation to the presentation of Jean-Baptiste. It needs to be of high quality, leading the content, the 3D content. That's the reason why we have the Paradata, leads to the story, to the memory, to the values. At the end of the day, the identity, isn't it? That's all about. And for that, the day will come very soon. We heard from UNESCO World Heritage Center, from Thomas, and from UNOSAT, the colleagues there, about the immersive environments. The day will come when the monuments will start talking. And then, I don't know if this is going to be a problem, but they will start, and that's the reason. And now, because of that, we have a specialist here about monuments, monument documentation, keeping the knowledge to be used or reused from archaeologists, from architects, from people, biologists, from civil engineers, geologists, and so on and so on. So, Raffaella, a professor from the Politecnico di Milano, a colleague, years long actively involved in the building information modeling systems, or in the HBIM, or better, HBIM, isn't it, Raffaella? Holistic heritage BIM systems. And here is, one example on how Paradata and metadata can help support building, setting up a knowledge. Raffaella, sorry, the floor is yours.
Yes, thank you, Marinos. Can you hear me?
We can hear you, and we can read even your presentation. Thank you.
Okay, thank you very much. I hope not to keep you many time. Thank you for inviting us, and thank you for all the people that presented before me. I'm fully agree with all the comments that have been done during this interesting afternoon. So thank you again. I am the scientific responsible of a lab which deals with advanced surveying techniques, especially on modeling for BIM and extended reality. And so thank you all to my group for the contribution that I am presenting. Just one comment on why Paradata in the 3D quality content models. Because first of all, architectural heritage complexity means that we deal with different purposes, different action, answering to each needs. Perhaps we have different purposes spanning from preservation, planned maintenance, communication purposes, as well as different funding sources, sometimes many money, sometimes, and it is the most recurrent situation, very low money for the surveying and modeling. But also the different survey phases that can be undertaken across different periods. So we achieve different accuracies in different portions of the complex monuments, archaeological sites, and so on, and also different actors. So what does it mean, this? This means that each involved actor and purposes decide a scale and accuracy that is coherent with the money, the objectives, and so on. On the other side, once the model, the surveying and the 3D model start circulating after this action, we risk to lose and to miss all the information that are at the base of the decision making on the surveying, the scale, and so on. Then, to guarantee that the data models can be reused and to guarantee the circulation and continuous knowledge circulation and enrichment of all these models, we need a memory twin. We need an holistic approach, as Marinos was remembering us, and we need parameters capable to describe, like the metadata, also the processes thanks to the Paradata. In our cases, the processes are linked to the scan to BIM to XR process, so spanning from the surveying to the modeling to the communication purposes across the web spaces, across the clouds. This means that all the different users that will use this model and reuse this model in the future, we need to guarantee them the proper information on the data sources in order to avoid any misunderstanding and misuses, especially in the case that we don't have the full scale precision model for the reason that I tried to summarize that it happens. We decided with Marinos to select this case study, the archaeological park of the Appian Way, that it is under UNESCO candidature. It is because I think that it is a paradigmatic case of the Paradata needs. The park is the largest urban park in Europe, about 5,000 hectares of protected areas, including environmental sites, landscape sites, the Appian Way itself, including also the monuments that are facing on the Appian Way, like the mausoleum that I will present, the aqueduct parks, the museum with the first digitalization of some remains. So we started to undertake the digitization of the park, huge big data, huge monuments, and we need to share with the responsible of the park, that it is directly depending from the Ministry of the Italian Culture. And we need to create a common line to make this data reusable for the future, then to make them comparable and to guarantee through digital twins all the information. I tried to summarize this information. We start from the surveying accuracy. On the left part of the slide, you can see all the precision that we achieved, spanning from the geometric network to the control points, to the LiDAR data, to the photogrammetry resolution in terms of radiometric, geometric, including also the not destructive techniques that can be postponed, and this is the case. It will be undertaken in 1 year. So when we start a complex survey in a complex site, we didn't close all the phases of the models just in one time, but it is supposed to be a sort of continuous line that need to be constantly updated with all this increasing information. But then it is once defining the grade of accuracy of serving of the photogrammetry, it is not enough, because we have also to span to the 3D models that we achieve according to the park objective, including the HBIM approach, including the level of development, level of geometry, the grade of accuracy of the model, the 3D model itself, but also the HBIM uses perhaps for the finite element analysis or the remote access for the XR. And this is the case. At the end, we have a map of all the precision that is required in function of the scale. Scale are very easy to be connected to a precision, because if one precision and one accuracy, it is not enough for a purpose, we can skip to another scale. So it is a very easy way to share information on the accuracy of the survey, but also of the model. Sometimes we have a high level of accuracy in the survey, but perhaps it is required a low level of accuracy in the modeling. But it is good, but the problem is that we risk, if we don't connect the information on the accuracy of the model, to transfer wrong information to the user in the future. So what we need is to share all these parameters. Now I have a sequence of slides where you can see all the Paradata that we started inserting: the responsible, the commitment, the level of detail, the level of geometry, the grade of accuracy of all the steps, spanning from the 3D textured model that you see on the right of the image, and till to the vectorial restitution, from where we derive perhaps the H-beam model with the precision, in this case, the precision of the profiles and vector restitution that we extract from the photogrammetric model and from the scan process. Here we have all the process from the that we name scan to beam to XR, that's to say all the process from the serving and on-site data acquisition till to the virtual reality and the extended reality that we are developing for some site into the in the archaeological park with web access, with the smartphone and so on. So for each of these steps, we tried to summarize and to tune the level of development and the level of geometry that are supposed for the new construction, and we tuned and we turned this definition in order to adapt them to the complexity of the architectural, archaeological, and cultural heritage. And then to document this, the log and LOD that we achieve for each monument and that we are digitalizing, including perhaps the log 100 that in the case of the new construction, it is just the conceptual phases, but for the architectural heritage, it is also important the collection of the historical report, ancient surveys, digital survey that can be made in the 18th and so on. Spanning till to the log 300, that's to say the scan to beam project, till to the beam uses the log 400 that is including the maintenance process, perhaps, or the beam to finite element analysis, till to the on-site construction, until to the log 600, that means the remote accessible cloud for the different purposes. This is the information on the generative model process, beam-enabled process, as maybe I don't want to bore you with the tool, but the BIM tool are not enabled to process complex shape. So we have to, we defined a protocol where to model the generative outside the beam environment, and then to obtain complex parametric object outside the BIM tool, and then to manage them within the BIM tool. So we can add all this information as perhaps the scale of the model, the H-beam model, in this case 1 to 20. But we can also have other scale. The same is for the log 400 for the maintenance. We start from the analysis of the decay that we can translate in the BIM, or perhaps it is the case of the vulnerability seismic check that in this case it is postponed to the 2025. So we have also to constantly update the Paradata for the serving phase that maybe are postponed together with perhaps the finite element analysis. And finally, we have also to document the elements that are no more existent, as in the case of the wooden beam and the wooden floor, that have been hypothesized and reconstructed in a simulation for the virtual reality. At the end, and it is important also for these phases to document the level of availability, existence, and so on. Just to give you an idea, all this model has been transferred to the industry that used the HBIM to realize the virtual reality. And this is the result of this process. Moreover, just the last two slides, moreover, we have also to deal with the level of information detail, not just the precision about the models, the serving, but in our cases, we define all the constructive phases, obviously defining a level of uncertainty, because sometimes we can analyze the stratigraphic units with the photogrammetry. We have documentation, we have archives, we have the ancient archives documentation. So sometimes we can better define the constructive phases of the mausoleum. Sometimes it is, how to say, a sort of gray hypothesis, but with few elements of demonstration. And also under this point of view, it is important to refer with Paradata on these phases. Here you see all the color we use in order to define the different phases, starting from the Appian Way geological formation from the lavic volcanic era that has been used for the mining and caves, but it is under one of the room of the mausoleum that is used in order to extract not just the basolatum for the Appian Way in the 3rd century before Christ, but also for the Middle East castrum made by Pope Bonifacio VIII, and so on. So we have a richness of information that we enrich and insert within the HBIM, as in this case, with the description, in this case, of the basement of the mausoleum dating back in the 30 years before Christ, and with the construction techniques and with the scale of the serving. Obviously, all this information can be exported together with all the other Paradata, and how to say, we are ready to implement all this information in a sort of core Paradata. I appreciated the last intervention, because yes, of course, as you can see, we have a lot of Paradata, a granular Paradata, and so we can also define a sort of progressive core with the demanding the granular information to the people that will use all this information and model. But for sure, the higher level of an informative level of informative models is not the BIM or GIS, but is the maximum level of data sharing through the web, through the cloud, obviously in respect of the fair care and the reusable data, no? But in any case, the most important thing is to make reusable this data in order to avoid misunderstanding on the reuse, because perhaps if somebody reuse this model that is not properly addressed so far to the vulnerability and seismic analysis. Obviously, even if part of the surveying are very precise, but we have also part of surveying that are postponed to the 2025 for a matter of funding. And we have to avoid that somebody can say, Raffaella Brumana is an expert in the world of surveying, so we can use all this data with the same precision. And it is not the reality of the complexity of the architectural complex site or archaeological site and so on. So at the end, what in my opinion we need for sure to define a common framework for the Paradata, where to implement and co-develop all together the languages, the tools, the formats, perhaps the XML, IFC, and so on. We need to define a standard in order to document the complexity of these heritage sites in an holistic way, as Marinos was underlying, holistic in the sense that we need to co-work among different experts on different disciplines, the surveying, the restoration, the maintenance, the XR, and so on. And this way, HBIM are part of the holistic approach. Is not an ending point, but is a through point. Very, very interesting because they allows to catch information beside and related to the object models, but in a certain way are a node of the holistic approach. And what we need is to define how to co-share these metadata and Paradata. So I hope that I use my time in a proper way. And last thank also to the groups that is contributing to this big digitalization of the Appian Way and of the mausoleum itself. So thank you to everybody.
Thank you very much, Raffaella. Very good ending presentation. Congratulations for your work. Yeah, and we are on time. It's even a couple of minutes earlier. Yeah, with one Italian speaker at the end. Yes, excellent, Rafael. Excellent, yes. What to say? I try to conclude now by saying we are creating by the 3D digitization in cultural heritage, big, complex, multimodal data for the 3D knowledge reconstruction. Yeah. So it's today we are facing the challenges in the 21st century for a multilingual approach of the content available. So not everybody can read English, not everybody can speak English, and so on. Not everybody can understand also what is the meaning or the correct interpretation. So if it's all about the reconstruction of the knowledge, then when monuments talk, then they need to have a special language. I would say this is the momentum, the challenges we have facing to be clear by the different multidisciplinary community of users. So the archaeologists can listen to a monument or can read the data, but can understand in a totally different way. An architect, that's exactly this, what an architect needs, that Raffaella presented to us. A biologist is interested also to see the biological films, for example, on the different materials or the different kind of materials and their conditions. The civil engineer, the material engineer, the chemical engineer, the geologist with the seismic information, the monitoring of all this information. And we had a couple of days ago a very, very strong earthquake in Taiwan. A report is coming now out about the state of the art and the different conditions of the monuments there. And of course, the language of a historian or even of a tourist is totally different. Yeah, all this together, it's the challenge, and that's why we need to document or digitize and document in a correct one way, in a standardized, in a universal one way. And that's why we need also the Paradata together with the metadata and the data together. As I mentioned earlier, it's a knowledge-based work that we undertake here, needs to have a high quality or quality of content, leading to the story, to the memory, to the values, to the identity. And we know what it means, identity in Europe. Europe, it is today what it is because of the result of the Second World War. And we still have wars. The first one war after the establishment of the Union was in Cyprus 50 years ago, 50 years ago. And we are still suffering because we haven't documented our memory, our identity. And then looting, distraction, and so on. So by saying all this, I'm opening the discussion session. We are on time. And we still have a few minutes to talk. Any questions, any comments, any remarks will be highly, highly appreciated. Drew is taking the floor and to give us an overview of this, what it has been posted on the chat. Drew, floor is yours.
Okay. Joachim, you've been...
Yes, that's pretty nice. I was really flushed by one object of the all nice talks, the sunbark. The sunbark touched me because it reminds me on a lot of...
Okay, sorry, you were muted.
On a lot of metaphysics which appeared in European history. So my question is if it's possible to integrate metaphysics, because during the European history it's rich of metaphysics, and I think it's high positively to evaluate them. So is this already a topic, how to integrate philosophy, metaphysics, so difficult philosophical systems? Like maybe in the case of the sunbark, because I think it's part of Egyptian resurrection context.
Yes, so I can jump in there. So at this time, no, we haven't started thinking about that, to be honest. We're just trying to grapple with just basic, the totality of Paradata and metadata and how to embed that into an immersive experience without distracting. And then, as you say, there's just so much more, and this goes much deeper. So no, we haven't, but it's interesting, and yeah, it'd be great to take that further, as Tomas already said in the chat. And you're, welcome to contact us.
Thanks so much. Great talks. Thank you for this quality.
I'd just like to point out that we're integrating metadata, metaphysics and the philosophy of science into the discussion right now. And, what is Paradata? Do we even need a term Paradata, or could we simply talk about scientific imaging? That's a kind of metaphysical discussion that we can do right now. And of course, if we're mapping stuff to the CDOCS CRM, it's quite relatively straightforward to bring in metaphysical beliefs of others and so forth and associate them with digital records.
So something we're doing in Dive into Heritage is, I mean, we do address intangible heritage, which at the end of the day, that's sort of what we're getting at. Sorry, can you hear me? My colleagues are quite loud right now. Okay, so yes, so we do address intangible heritage, but it's detached from the model in some sense, except where it's built into the narrative experience. So it's not a part of the Paradata and metadata, and perhaps that's where things need to change.
Thank you very much. Jochen, you want to?
No, I just want to put my hand down, but it doesn't work. It's difficult. I want to put my hand down, but it doesn't work. Sorry.
It's a metaverse hand. I don't know. It's out of, yeah. Yes, we have another one colleague, but he's identified here with a number, probably his birthday, I don't know. Yes, 1995 user. Gentlemen, no?
He's muted.
You are muted. You are muted. If you turn on your microphone, please.
Nelson.
Yes, Nelson, if you can please turn on your microphone. Turn on your microphone. Yes,
can you hear me now?
Hear you.
Okay,
yes.
So I'm sorry to come with such reality issues, which are greatly connected with the new energy performance of buildings directives. Something coming which is called minimum energy performance standards that may oblige many of our historic buildings to be energy performant according to the new century rules. And this is just to bring to the attention that all these metadata, paradata, and 3D scanning can also be used to evolve the knowledge of how our previous generations managed to build buildings that were comfortable, sustainable, did not use so much energy, etc. So we need also, not only for remembering, we need to put in some energy guys in these digitization groups to make sure we really understand how buildings used to work with a lot less energy than they do now, and try to save them from insulation from the outside or inside. So it's really interesting to look at our grandparents, and they used curtains, they used fossil energy inside the house, which is not so good, but we need to find in this past future some way to get to the sufficiency levels we need for being sustainable. So that's just my contribution, not only HBeam, but also HBAM and some knowledge. Thank you.
Yes, very good comment, Nelson. Thank you very much. Yes, the language of a monument or of even a three-dimensional artifact, structure, needs to tell us or send us out the message about its construction and production technologies used on that time. And of course, if you are at Parthenon, you don't want only to know about the, what this building means for the humanity so far as democracy concerned. But if you are an architect, yes, you can be speechless to see what a genius engineering was on that time. On a momentum when today we talk about the Industrial Revolution 4.0, yeah? If all this information, first of all, if we manage to digitize and bring it to a structure that all this multidisciplinary community can understand it in the correct one way, then here is where we are, to redefine the definition of the industrial revolution. Yeah, it's going to be 40.0, not 4.0. But we have now also some other comments through. Yes, Ronald, floor is yours. Ronald is the vice chair of IIIF committee or working on the 3D standardization. Ronald, the floor is yours. Ronald, we cannot hear you. Ronald? Okay, is anybody else?
So, Ronald is sounding like a bee stuck in a pot. So, hello, I'm Drew Baker. I'm work for the UNESCO Chair on Digital Cultural Heritage here at Cyprus. I just really want to say thank you to everybody who's attended, especially to Daniel, Mark, and Eric, who know where the whole Paradata concept came from, which Paradata in 3D, which is back on a project which I ran in 2006. And I'd like to thank obviously Marinos and also Esto for carrying that forward. And there are 5 things which I wanted when I was trying to describe what Paradata was. I wanted a way to record the process that went into the creation of a 3D model. I wanted to be able to show the rationale that went into it to help to stimulate scholarly debate. I wanted to be able to reuse that model to speed up the development process and to lower the cost of development by having an approved model, if it were, something which scholars would have a confidence in to be able to use. Fourthly, I wanted to be able to use Paradata to defend the visualization and to make the point that it was more than just being purely illustrative. And then lastly, I wanted to be able to have the model to be citable, just like a paper record, to actually have the object be able to be qualified, because it, after all, is a visual hypothesis. And I think we're edging towards that after almost 20 years. With things like the digital lab book, it's pretty much what we wanted. You know, it was, yeah, like, show your workings out, as we were always told in school. If we've got that, then we can show it. On the reuse side of things, you know, Eric's done sterling work on being able to think around that subject. Isto has looked at the way that things have changed over that past year, because when we were originally talking about Paradata, it was about the visualization process. You know, it was about how you capture that creative process. It wasn't necessarily the hardcore scientific level of capture that we have now. And it's people like Marinos who have been able to come along and bring that new technology, that scientific aspect to the creative purpose. And then we have the long-term digital preservation stuff, which was something which we never even thought about. It was kind of, well, you know, it's going to be useful. And then we have the archivists coming along and saying, if you do your Paradata, even if we've lost anything else, we understand how you got to the point. So from small seeds, we've created a huge monster. So thank you, everybody. So I think this has been really, really heartening for me, and also I think really informative and really exciting. And we have another session because we had so many people who were interested in discussing that and sharing their experiences. For those who are interested in statistics, we had 377 people on today, which isn't bad.
And that's from all the parts of this planet, yeah? And amazing to see that a few people, even if they are in Australia, they are still with us together. And of course, San Francisco joined us now. And it's amazing to see how around the globe the people stayed to follow these presentations, this event today. The message is Paradata, metadata, and data are three important components for the reconstruction, for the three-dimensional reconstruction of the past. We need to take care during the time of the digital transition, digital transformation, digital century, that we put at the end of the day, or create at the end of the day, a universal guideline, a standard which can be used for everybody. Anyway, in the area of the documentation of the past, there are just only 2 or 3 standards available, but so far as that concern, there is not one, and we need to take care. The academia, the research, and of course, the industry and the stakeholders together have to take care that this, the soonest, fastest is going to be realized and implemented. But we still have a few times more. If there are any other comments, questions, this what I will say is that out of this event here, a book is going to come to be published in a few months from now. All the presenters are going to submit a paper, and that's going to be under open access, the book. So free of charge and available for all of you. We will keep you informed. Carla, the floor is yours. Please use your microphone.
Thank you. I think you can hear me. I just wanted to add to all of the discussion. There's a big focus in this particular session on 3D, which is clearly an important area, but I think our approach at Cultural Heritage Imaging is to say there are many, many ways to document things, and 3D is one thing in the toolbox, but documentary photos, RTI, multispectral imaging, other kinds of scanners, x-rays. I mean, there's so many different ways to document things that what we really need to be thinking about is how to push this idea of transparency, which goes back to what Drew was saying as well. It's all about do what you need to do. What people are going to do is going to depend on the tools they have available, the skill sets that they have available, the budgets that they have available. We want to encourage as many people as possible to document things and to share those things, but do that in a way that other people can understand what you did. So our approach is about transparency. Not about, oh, there's some specific standard for a 3D model. It's about transparency. Do what you need to do with the budget and the skills that you have. Keep track of it so everybody else can figure out whether it's going to work for their needs. You're going to make it for your needs. Other people need to figure out if it meets their needs. And how we do that is through transparency. And I feel like that's where the conversation needs to be, because that's the only thing we can control. We can't control all the other aspects that people are doing. We can have standards till the end of the day, but not everybody's going to follow them.
Ronald, you want to try to another one time? No, it doesn't work. It doesn't work.
One more time. Any better?
Yes, Ronald. Yes.
Okay. Can you say something back?
We can hear you in a very nice way.
Excellent.
We can understand even.
I've evolved from the B sound. Sorry, everyone. I put in a couple of brief notes earlier. I was glad that someone had mentioned about IIIF 3D. And there's a technical specification group and a community group if you're interested. Open standards, open web standards. And indeed, following on Carla's point, hello, Carla. There's a standard for 2D. There's standard for audio and video. People were mentioning sound earlier. And that's becoming a sort of de facto way of digital collections, libraries, and archives to interchange. And the interchange is going to be important to build any kind of metaverse. So the 3D specs we're putting together is to try to pull things from disparate collections and reassemble them or assemble them in a new and interesting way. All that hopefully will be of interest. I'll keep that brief. On the metaphysics concern, it's glad that was mentioned, and I think that's key to the whole memory twin thing that Marinos, you and others talk about. What is this thing and why was it put together? Why was so much energy and commitment put into that object or that artifact, as well as why are we putting so much energy and effort into it? You know, our metaphysics coming to it as well, which is, I think, fascinating, including different belief systems and different eras, which is curious. And I've put a link in the chat. Marinos, Drew, and I are involved, and some others perhaps here, on an X-archiving initiative based out of London. And one of the things trying to do is pick up on Drew's earlier work on the London Charter and try to update it for some of the current things we're talking about here. So thanks very much. And I'm glad the sound worked.
Thank you very much, Ronald. Carla, my comment to this, what you said earlier. If an image, Carla, doesn't matter now if it's a camera image or spectral image, whatever image it is, the representation there is worth of 1,000 words. Then what shall we say about the 3D structure? Yeah? Is worth of a story, yeah? And the memory. And we need to take care that it's correct there. And the project, you know, with the name acronym, Oerika 3D, is going to contribute to make at least a step forward in this direction, and I'm very thankful. Our coordinator is also online. Antonella, I don't see you, but if you are there, if you want to say a few words.
I'm here. I attended the whole seminar and I learned a lot. So I would like to thank all the participants, Marinos, to have organized it, and the quality of the presentations. I'm full of notes. Just to reply to your question, if a picture is worth, how many words is worth, what happens with the 3D is worth much more. I think that it depends very much on what we discussed today. It depends on the quality of the information that is around the complement, the 3D object. Because per se, the 3D object can be even less meaningful than a picture. Because it can give the impression of something that is artificial. It is through the documentation, the Paradata.
Antonella, if you can please take your microphone. Yes, exactly. And if you try again, please. Yes.
It is through the holistic documentation, the Paradata, the metadata, whatever we discussed today, it is through the whole information that is around the 3D object that the object becomes meaningful in the cultural heritage domain. So thank you very much for the seminar, because I learned a lot, and I guess that Eureka 3D is the project where we are experiencing many of the things that were done today, and we hope to continue in this direction with all the other initiatives that were mentioned today. Thank you very much.
Thank you, Antonella. But the thanks is going to Anthony too. It's Europeana's fault with this Twin IT initiative, and of course of the European Commission. Yeah, not to forget with all this what they said as a focal, let's say, activity this couple of years for the documentation of the past, and especially the 3D domain. So, yeah, that's because of you we are here, Antonia. That's why you keep all the people here. We just did the job free of charge for you, yeah? But, okay. But you are good. You are a success story. What to do? Yes.
Well, you are the success story today, Marinos. This webinar is the success story.
Well, that's all the participants, all the speakers, and we are really, really very thankful to all the hundreds of people, actually 714 registered participants from over 80 countries of the world. It's amazing. And that was just only 1 month of preparation to go for this workshop. And really, really, really thank you even to the 50% of the participants now online, but several people said, look, something happened now, we cannot be online. Please make a recording and we will follow up. So on the 17th of May, we are going to be back again. You don't need to pre-register, but if you know other people who would like to register, please inform them, please distribute the message, and we will take care that we will continue in this direction. And of course, because we are Europeans, what to do, we will help and support Europeana. And of course, Europeana is supporting everybody. Yeah, there is even a Europeana China project, isn't it? Or it was some time ago, Anthony, isn't it? Initiative and so on. So I'm sure that Europe can help and support in all the different, let's say, on digital cultural heritage areas, domains, and so on. So big thanks to everybody and to all the participants from us. And if you can see, it's amazing having all those participants from all the world, speakers, especially from Cyprus and from Italy, not to forget. We managed to be, but okay, we have through here, English time, English time. So we are finishing and we are on time. Ladies and gentlemen, dear colleagues, thank you very, very, very much. It's highly, highly appreciated. Keep in touch and we will soon be back again. Thank you. All the best. Have a nice evening or a nice day, wherever you are. Thank you. Bye.
Bye-bye. Bye. Thank you.